Then we will start understanding how we start manipulating the data, extracting the data, understanding and applying basic data cleanup techniques. We have to prepare the data set. We have to clean the data set. Because as you can imagine, when we access the data from the GEMS food database, mainly we will have data coming from different sources, having different levels of quality for this data. So we have to perform cleanup procedures before we could use the data set. And then we will start discussing how the electronic working group or JECFA working on this particular terms of references will start initiating some overview, some descriptives about the data. Then following to that, we will have a presentation with Dr. Eli explaining to us the basic statistical steps and analysis we will start performing on the data set. As you can imagine, when we have a distribution of data points, when we have a data set, مجموعة بيانات, we have to start doing some statistics on it, right? Descriptive statistics, إلى آخره. So we will understand that with Dr. Eli. Then I will have a third presentation in order to discuss what we call the rejection rates calculations, and we will understand that further. And we will finish with Dr. Karima with a presentation describing how setting maximum level will help reducing the intake, تخفيض التعرض, okay? And finally, after lunch, we will go to our breakout rooms and we will do the calculations together in order to have recommendations to set maximum levels. That's okay for everyone? Great. So what is this procedure to set maximum levels? So these are the steps described by the document by CCCF to be adopted or to be followed in order to set a maximum level. One, data extraction, to identify the data set for a particular terms of references. We have a question, we have to identify our data set. We will discuss that. Two, we will perform some data selection cleanup. We will be cleaning up, removing some outliers, removing some data points. Three, we will start doing some overview analysis, generating some descriptives to this data set. What we call descriptive data exploration. So we will start exploring our data points. They represent which geographical regions? Do they have proper geographical representativeness? Do they respect the timeline set in my TOR, etc. Step 4, we will be performing some statistical analysis of the occurrence data, analyzing the distribution of the data set, having some figures, right? Having some histograms, some representations of the data, and some descriptive statistics. 5 and 6 is the core of the steps to be adopted in order to set ML. And we will be having further discussion with Dr. Karima about the ALARA principle, the as low as reasonably achievable principle. That is the principle adopted by this committee in order to set MLs, or to be adopted for contaminants in general, to set MLs, which is based on a compromise, توافق, between the safety aspects and the economic and the trade aspects. Because we are aiming to protect, but at the same time, we still want to preserve fair trade of this food commodity. So we have the fair trade, we have the food security issue, but we have the food safety issue. And the idea is to have a compromise between both. How we will be having this compromise? By evaluating the economic rejection rates, how much we will be rejecting commodities if we adopt this ML. That's the economic aspect. And calculating the exposures, okay, or the intake, in order to see if we enforce this ML, how much we are reducing التعرض. Then we have to compromise between both according to the ALARA principle, and we will have recommendations to adopt an ML or not, okay? So these are the procedures. So please, during my presentation, if you have any questions at the end of my presentation, we will discuss them. So we'll have some time for questions. Let's start by the data selection. So we have a TOR. What do we mean by TOR? The Codex Committee for Contaminants and Food had a meeting and they discussed to launch a new work or to continue with the work let's say, setting some MLs for a contaminant for other commodities, etc. That's the work of CCCF. And as Professor Sam said, they worked a lot on lead recently, الرصاص. Now they finished working on lead. They will be working on arsenic now. Before, they've been working on cadmium. So we have always some TORs, terms of references, for electronic working groups to set MLs. So the TOR will be defining the task. Once we have the definition, the question for our task, we can apply the filters. You remember the GEMS food database has filters. I will be selecting the contaminant, the time frame, the region, global, particularly WHO region, etc., in order to extract the data. So that's the first step. I will extract my data from the GEMS food database website. Only data in the GEMS food database should be used. However, we can use non-GEMS food database coming from the literature, from reports, only to inform further understanding of the data. Okay, but the major important source of data for the proceedings of CCCF should come from GEMS food database. That's why we had this extensive discussion about the GEMS food yesterday. How do we extract? By applying filters. So this step is normally performed by the GEMS food administrator. The electronic working group chair will ask the GEMS food administrator, please, can you send us the data set according to these TORs? Or normally, if we have an account, as we said, we can perform the step. But they tend always to apply the step in coordination with the GEMS food administrator, just to avoid any problems with the data extraction. And actually, this year during the session, we had a problem related to data extraction. So it's not a problem we can't have. It's a problem that we can very easily have. Now, we discussed that yesterday. In some instances, we can submit data directly to the electronic working group or to the electronic working group chair. Okay, like during the proceedings of the electronic group, working group, one country will say, oh, but I have a data set also that I can submit and we can use. We can do that, but the proper procedure is to submit through the GEMS food database. Now, these filters that we'll be applying or that the GEMS food administrator will be applying will allow the analyst, us, the electronic working group members, JECFA experts, to identify data respectively to a particular call for data. And we had yesterday an example of a call for data, right? So normally it's very specific, the call for data. Best to consult, as I said, with the GEMS food administrator in order to avoid any problems. And in case you remember, we had the option to say that it's confidential or not. So the GEMS food administrator will be handling the confidentiality issues. So, which of the following statements is true according to our discussion regarding the use of data for ML setting in Codex work? All data from any national database can be used without any verification? No. Only non-GEMS food data are used to derive MLs? No. GEMS food database data are preferred. Non-GEMS data may be used as a supporting data, right? And literature data should always replace or be present in our study? No. But according to our discussion yesterday on published data, still published data can bring a lot of interesting information. We have our data set. Okay, it's an Excel worksheet, or we are using any statistical software, okay, or any software used normally for risk assessments, okay? We will have our data set. The first step is to start cleaning up our data set. The cleaning up step is to remove non-relevant or inappropriate samples or data points from the data set before analyzing the data set to recommend MLs. It's a crucial step. We cannot have a data set raw and start using it. We will have distorted MLs. What are the situations that will imply a cleanup of my data? For example, samples that are clearly outside of the TOR. My TOR, I'm working on tomato sauce, and I have data points on ketchup samples. So obviously, anything related to the food mapping classification will help me to remove some data points. Okay? Second reason, samples that are outside the date range of the TOR. Yesterday, we saw in our call for data for total aflatoxins, they wanted data coming from the past 10 years. So if I have data before the 10 years, I will remove them. Samples missing crucial information. And we studied yesterday the template and what were the mandatory information and the optional informations, right? So any mandatory missing information, here normally the GEMS food administrator, if we have a very important database missing some important information, the administrator can right away reach out to the data provider in order to ask to complete this information. Let's say it's very important to have it. If it's not important to have it, we will remove it. Some missing crucial information could be, for example, the state of the food analyzed, and we are aiming to set an ML for a particular state of food. So if we're missing this information, I will remove the data point. I have also a wrong local food identifier. Let's say I'm missing the second level of the food mapping. Okay, my second level of the food mapping, and I'm setting an ML for this particular food identifier. So I will be removing this data point. Samples with unacceptable analytical performance criteria. Okay, for example, I'm studying my data set, and as analyst myself, I saw values of LOQs that are not logic, okay, or logical. I can ask again, if the data set is very important, I can reach out to my data provider in order to ask why. But if I'm suspecting an error, a serious error in the analytical criteria, I will be rejecting or removing those data points. Okay, so unacceptably high LOQ, or they are submitting the value of LOD higher than the values of LOQ. So I have like a serious problem in my data set. Or I have a problem confirming the accuracy of my data. So I have problems related to my analytical quality, which is a serious problem, right? How can we accept a data value, a result, if I'm not sure about the analytical quality assurance of it? Always, I will not reject right away because data points are valuables. I need data points for my Codex proceedings. However, if I cannot do corrections, I will be rejecting. Data for which the information on the portion analyzed is not clear. Example, peeled versus whole fruit, or husked rice versus polished rice. And if you check the MLs in the CCCF, you will notice that for rice, we will be mentioning or detailing or giving more specifications. For example, we have husked rice, we have polished rice. So if I'm not providing this information, how can I be sure this data point is corresponding to husked rice or to polished rice? So normally I will be removing this data point again from my data set. Always, if the data set is important, I will start by contacting the point of contact for the country. And now you understand why it is important to have a point of contact. So when we have a jiha submitting the data, it's important to have a point of contact handling this data provider or this data providing step. I can always have assumptions. Okay, I'm not in our discussion during this morning. We will not be going too much into different scenarios and assumptions. But as you know, in risk assessment, I can go for several assumptions. I can always adopt some assumptions according to my objective. But if we will start detailing the different scenarios and assumptions, that comes with the experience of handling the data. What do I mean by assumptions? I can always assume that I will accept this data point, but I have to prove it. Data, that's a very important information. Okay, and since now today we will be speaking about lead, and we will be again taking lead as an example for our proceedings today, it's very important to discuss and understand this part. data originating from suspected, fraudulent, or economically adulterated samples. So when we, again, let's remind ourselves, we are submitting data, for example, coming from a monitoring or a surveillance program, right? Among the samples you collected, you will have samples adulterated, right? Right? And I will give you the example, for example, of spices adulterated with lead salts. It's a very commonly known type of adulteration. And if you recall the big problem of cinnamon contamination with lead during the past years. So it's a very well-known type of adulteration, okay? So let's say I'm collecting samples and I requested and my lab has a data set, right? And I requested my lab to provide this data set for me. The lab will be providing all data results. Among these data results, I might have results for adulterated samples. And I will upload them to the GEMS food database. Now, the electronic working group is doing the cleanup. It's very important to understand and to remove data points where we suspect adulteration. How we will be suspecting adulteration, do you think? I'm studying my data set for lead and I have a series of results. Very high. Let's say I have my distribution and then I have data points which are extremely outliers, extremely high, even visually or manually when studying the data set. Okay? Or I have a knowledge, I can go to my literature and I have the knowledge what is the normal range of occurrence of this contaminant in my food commodity, right? So if I see extremely high results, normally I should be removing those results. Possible signs of this fraud, certain samples are orders of magnitude higher than others. So they will be removed from the data set. It's very important also to discuss this issue of temporal variability. Why we are requesting data going back to 10 years? ليه عم أطلب بيانات بترجع ل10 سنوات للخلف؟ And it will depend on the contaminant itself. Let's take the paradigm or the example, the comparison between heavy metals, for example, lead, and mycotoxins. If I tell you mycotoxins and climatic change, what can you tell me? Okay, let's ask the question in a different way. Do I need to have data for mycotoxins for the past 10 years? Yes or no, and why? Okay? And please take a microphone and let's listen to your opinion. What do you think and why? Yes, Abi, please, let's have the microphone here. You, but just to give you the microphone.
يمكن رح أتكلم عربي فيما يتعلق بالسموم الفطرية. من المهم جدا حسب رأيي يعني وحسب الخبرة فإنه لازم يكون هناك نظرة شاملة ما قبل يعني ظاهرة التغيير المناخي وما بعدها، لأنه هي تتأثر بالتغيير المناخي خاصة من ناحية إذا كان التخزين، ارتفاع درجات الحرارة، الرطوبة، غيرها، فتأثر طبعا أكيد على مستوى الميكروتو أو يعني إنتاج السموم الفطرية في
Absolutely. Okay, thank you. Yes, تفضل. And please give me your opinion now comparing to the heavy metal situation, for example.
بالنسبة للسموم الفطرية يلي هن نحن مقسمهم لثلاث مراحل، بمرحلة الحقل ما قبل الحصاد والتخزين وخلال التصنيع. بمرحلة الحقل بسبب التغير المناخي والثيرمال دروب والرطوبة والتصحر كثير عم نشوف أبحاث بتدل على ارتفاع السموم الفطرية بالحقل يلي هو ما مفروض. يعني عندنا الأسبرجيلوس والبنيتيديوم يلي هن يعدوا من فطريات التخزين عم يتكاثروا وعم يفرزوا سموم بالحقول حسب اكيد تقارير الاف اي او والورلد هيلث اورجانيزيشن. والغريب انه بمنطقتنا العربيه والحوض المتوسط كمان عندنا هاي الظاهره بسبب التغير المناخي. كل شيء ناتشورال كونتامينانت بحاجه دائما لداتا قديمه ولحتى نشوف الفلكتويشن واللي هي عم تتزايد بسبب الكلايمت تشينج.
Absolutely. فإذا الجوابين كافيين ووافيين. So we need to have a long time frame in order to have a proper vision of our data. If we take the example of lead, we had a brief discussion in my group yesterday, and Professor Samuel evoked also other mitigation strategies like the adoption of a code of practice. So they will be requesting also data from before the implementation of the code of practice and after the implementation of the code of practice, because we need to understand whether the code of practice has an impact or not, for example. Okay, so that was just a brief discussion in order to reflect about the time frame, okay, of the data available. Now, we had yesterday this discussion. We're still discussing the cleanup of the data set. Data coming from targeted and random sampling, we discussed it a lot yesterday. Targeted sampling is biased. We are aiming to have a data set, the most representative, okay, in order to use it to set our MLs. So in a lot of situations, we will have a restriction and anything coming from targeted sampling will be removed from my data set. And you remember yesterday in the fields of the GEMS food database, they are requesting to provide the information. It is targeted or random sampling. We can still have biases, okay, even in my random sampling. And we discussed that briefly yesterday. The way, are we properly applying the random, the statistical definition of the random sampling or not? But in all situations, we will be assuming, we will be adopting, we will be using this data set with the knowledge of the uncertainties or the bias coming with it. Now, that's the most important reasons to remove data points, okay, from my data set. But now, do you think that removing outliers should be a manual and a visual step that we do, or we should be adopting some statistical methodologies in order to perform this step? What do you think? The fact of detecting the outliers in order to remove them. We can still apply the manual or even the visual study of my database in order to remove my data points or to apply the filters that we discussed. Let's say it's outside of the TOR of outside the terms of references of my electronic working group. But then I can apply also some statistical tests for outlier removal. What do you think? Absolutely. So we have to have a consistent and a standardized approach. We have to have a consistent and standardized approach. That's the first idea. The second idea I wanted to discuss with you, and very important, outliers or extreme values not to be discarded unless there is a valid reason to do so. And that's a very important information from the start. Okay, we discussed that. If we do not have a valid reason, my data point is very valuable. It can enclose a very valuable information. So I will not be removing data points just for the sake of removing data points. I need to prove it and say why. Why I might risk lose some information? Because heterogeneity of contaminant distribution perhaps is a very important information, as we know in the case of mycotoxins. So if I will be removing automatically high values, perhaps those high values are representative of some certain levels of contaminations. And I have to take into consideration the sampling here. It's very critical, the sampling, when we do mycotoxin analysis, because of the heterogeneity in the distribution of the contaminant. So if I see a high value, I will not be removing this high value automatically. I have to understand. Or due to other natural variation. Perhaps if I'm removing those extreme high values, I'm removing a very important information that can describe a natural occurrence, a natural variability in the distribution of this contaminant. Okay, in some instances, and I told you, we face a lot this problem. In some instances, we see some very, very high values. Like, let's say, obviously, let us go and check the unit of those values. In a lot of instances, it's related to an error with the unit. That's why we insisted yesterday, please pay attention to the unit when you submit your data. Is it a milligram per kilogram or a microgram per kilogram? So if I see very high values, I will not go automatically and remove them. I will try to inspect a bit to check, perhaps it's a unit problem. And I will do some corrections here. Okay, and the results, but as we said, the results where we suspect fraudulent behavior or adulteration need to be removed from my data set because they are not representative of the normal occurrence of my contaminant. Okay, and they will be driving my ML what? For higher values or lower values if I keep those high values related to frauds? To higher values, okay? So I'm distorting the procedure of setting my ML and it's no more representative to my situation. Now, in the document, if you check the document, they are explaining some statistical and sometimes very simple tests that we apply for outlier removals, okay? And they say you can still adopt the visual approach, which is not recommended, okay? But they say it clearly. If you obviously clearly see that you need to remove some data points, even when visualizing your distribution. So what I'm visualizing here is the histogram of my data set, the distribution of my data points, okay? If you notice that you have some data points which are obviously outliers, you can remove them visually. But you can still, or you need to apply some statistical tests. For example, one very simple approach called the interquartile approach. So I have an interquartile range, which is the range between my 25th and 75th percentile. That's my range. And then I will consider any data point above this interquartile range times 1.5. I will consider it as an outlier point. That's the approach that we call the interquartile IQR approach. It's a very simple approach. We can apply it using very simple statistical softwares, even Excel, and it will allow me to say that if I have extreme data points above a certain limit or value, I'm considering those data points as outliers. Now, let's continue our discussion, and here let's tackle the issue or the discussion related to the LODs and to the LOQs again. In the case where no LOQ or LOD is provided for a specific data set, what do we do? And we also started the discussion this morning and evoking again this problem of LOD and LOQ and why we need at least the LOQ in order for us to be able to work with our data set. But in case I have like a big data set coming from a very important country in the data set I'm studying, and I'm missing LODs or LOQs. First, the submitting country organization or observer should be contacted. Okay, so they are saying in the document, not may or can be contacted, should be contacted. In order, as a first step, to obtain such information, to ask them, please, your data set is very important. Can you provide the information related to LOD, LOQ? In the case where the data set contains nearly only quantified results, the majority of results are quantified. Even if I'm not accessing the LOQ, the document or the guidance is telling me that I can use this data set. Again, if the data set coming from a particular country or observer contains mostly quantified data points, even if I'm not accessing the value of the LOQ, it's not a limiting thing. I can still use it. In the case where the data set contains a significant amount of left censored data, what do we mean by left censored data? Mostly what? Very low values or very high concentration values? Very low concentration values, okay? So they are telling me in the guidance, in the case where the data set contains a significant amount of left censored data, individual data without quantified values, meaning below the LOQ, generally referred to as data below the reported LOQs or LODs, data set should not be used if I don't have the value of the LOD and the LOQ. Yes. That's an excellent question. Okay, but that's a guidance. I will have an answer. Okay, that's a guidance document. We cannot go to overly define and set all the rules. Otherwise, we will not be able to work with the databases we have. Yeah. I got your point. That will be the decision to be taken by the electronic working group or JECFA working on this data set. Okay, and the guidance document, we don't have this information. And we know why. Strict rules, no.
I mean,
Yes,
I mean, this way it become, it will not be objective anymore.
Yeah, I got your point. But in a lot of instances, and that's also the difference between, if I may say, the difference between the assessment and the management and what we're saying. In a lot of instances, you have to take assumptions but be transparent about the assumption you took. You will write it down and you will be transparent. Okay, that's the spirit of the work.
I mean, do you think their decision would be based on some guidelines that they have and we don't?
Perhaps a certain committee or a certain electronic working group, they will be agreeing on some guidance to be applied in this particular case, and they will disclose it. Okay, but that's a very excellent question. In the case where an LOQ is provided now, so, okay, for the situations where we accept, we reject automatically. Now, in the case where an LOQ is provided, identify a cutoff level for the LOQ depending on the MLs being considered. So we saw yesterday in the call for data, right? They had a very clear cutoff for the LOQs. We will not be accepting data points coming from methods that have LOQs below this, higher than this value, above this value. It was clear, the cutoff. Okay. For example, they are telling us you can fix the cutoff, any value below the ML to be discussed, okay, or the hypothetical MLs, or LOQs below half the ML under discussion. But in all situations, I will be accepting data points with methodologies having LOQs below the ML that I'm working on, right? The data set contains a significant amount of left sensor data again. Further contextual information should be considered. And that's the answer for your question, Lalama. Okay, so I have my left sensor data set. The document or the guidance tells us that further consideration or contextual information should be considered in order to take a decision. For example, this data set comes from a very important producing country. I will not discard this data set automatically. Perhaps I will accept. Okay, so that's the spirit of it. So data that appear as outlier or extreme values should always automatically be excluded from the data set during cleanup? No, I have to try to bring some corrections. If I'm not able to correct or to improve, I will be removing them. Why should data from targeted sampling generally not be used in setting ML? So we had a lot of discussion. They are too expensive to analyze. No, they overestimate typical exposure and are not representative. Yes, right? Because normally when I'm going for a targeted sampling, I'm dealing with some emergency situation or a contamination problem. So the values will overestimate the natural occurrence of this contaminant. They include only processed food? No. They contain duplicate entries? No. So that's B. Okay, so we're good. Targeted is biased. It will overestimate. So that's it, mainly related to the preparation of the data, cleaning up the data. So these were the main information for our discussion then, today. But then during the practice, you may face a lot of different situations and you will have to take decisions. You will have to deal with that, okay? But the most important take-home message is that we need to clean up our data set. Always we will have data points to be removed. And then my data set will be ready to start with the statistical analysis and then the things we will be doing. But before diving into treating and applying and analyzing my data set now, which is clear, which is clean, normally the electronic working group will try to visualize some information, okay? try to visualize the database, having some figures, some histograms, some tables, classifying the data points per country. It's important, this information, right? Why it is important to study the country distribution of the data points in order to make sure that my data set is geographically representative. Okay, that's very important. Or have a classification by the year. That's why we were requesting the year in the template. We're requesting the country in the template, etc. So all steps taken in the data cleanup and the rationale and assumptions made should be provided. Everything, when you remove a data point or a group of data points, you should explain why. Useful to provide information on the major production regions for the commodity under discussion. It's always important to have a particular look to the data points or results coming from a big producing country, right? So it's very important to have a deep look on the geographical representativeness and the time period representativeness. Then, geographical coverage of the provided occurrence data. When evaluating an ML for a particular commodity, the data set should include representation of production regions that are important to international trade. So the idea of production and always the idea of keeping a fair trade, not disturbing the trade, okay? Data from importing country also might be very important, but also might be biased in the food, if the food has to comply with the requirements, right? When I'm an importing country, I will be verifying the compliance. So my data set could be biased. So I have to take that into consideration. But normally, when we extract what is practiced, they extract data points coming from different countries, producing countries, exporters, importers, and they consider all the data points from all these countries. Additional content, why? Why also it's important to consider other than the producing countries? Because the result coming from the producing country is coming from the commodity analyzed at the production step, right? But a lot of contaminants and the example of mycotoxins can occur during the transportation, the storing, until they reach the importing country. So it's always interesting to have the result from the importing country. You see, we're discussing always the pros and cons of everything. Provide separate, in some instances, it might be interesting to provide separate analysis. I need here to separate between the producing countries. I will do my full system analysis and the importing countries. That's few examples for you to think of. Only if there are enough data that show an indication of large, that's a very important information. And Mrs. Nuha, Professor Sam can attest for that because we had a huge discussion during the past CCCF. And fortunately, this information is well clearly indicated in the document. Only if there are enough data that show an indication of large differences in reported levels between regions or between countries in a region, analysis could be performed by region or country. Otherwise, we have to perform the analysis globally, okay? And we had a big discussion during the past CCCF because one of the working documents you will be studying with Dr. Karima today, item 5, and you will see, please remember that when you go to your breakout rooms, you will see an analysis performed for the global data set coming from all countries, and you will have the same analysis performed for the data set coming from the PAHO region, from a particular WHO region. And then they provided the same analysis for both, and we didn't understand why they separated between the global data set and this particular region. And unfortunately, I will not continue regarding the adoption of the ML. We can have the discussion afterwards, okay? But just for you to think about it during your breakout rooms, why do I need? Okay? Do I have a rationale? If I have the rationale, that's perfect. One of the rationales could be that in this particular region, the climatic conditions, agricultural practices, etc., could induce higher levels of this contaminant. So we should pay attention to the situation of this region. Otherwise, we have to take the global database and a global geographical representativeness. One further idea, if no geographical representativeness, I requested my GEMS food administrator to send me the data set. And they sent me, or I extracted the data set. Unfortunately, I only have data points coming from the EU, for example, and the US. I don't have data points coming from Africa, from India, from China, from other producing countries. Do I discard this data set automatically? No. So we're trying to have this way of thinking. I do not discard it automatically. I have to understand. Is it important to set this ML? Can I compromise? Can I take and accept this assumption? If I can do that, I will use it, even if I don't have the ideal geographical representativeness. Right? Yes. And excellent. So normally in the decisions that are taken, and when the CCF will take the decision, in this situation, they can recommend to review the MLs after 5 years or after 3 years. Okay? A time period coverage, so we discussed that in details. In some instances, it is very important to have the time going back to 10 years, and in other situations, no. Okay, it's important to understand that. And particularly for the situation of the implementation of a COP. So we discussed that enough. So we also answered this question. If occurrence data lack full geographical representativeness, Codex cannot proceed with setting an ML under any circumstances? No. So we're now understanding there is no any, absolutely not, should not in the Codex. Okay, we have to study our data set. We have to understand the data set. So as a conclusion, and then we still have few minutes if you have further questions related to this step. Let's recap. So we have terms of references. We need to set an ML for a particular contaminant for a commodity. The first step, which we discussed now, is to extract my database, work with this data set, clean it up, remove any outliers, understand the assumptions, document the assumptions, please. For everyone amongst us working on writing reports and assessment reports, document, okay, everything. Be transparent in this step. Have a paragraph and the methodology well explained related to the data preparation or data cleanup step. After we cleaned up our data set, we can look at the geographical representativeness, have some figures, tables, okay, the time representativeness. And now I'm ready to start my statistical treatment, my proper statistical treatment of these data points or this data set. Okay? Any questions? We can still have 1 or 2 minutes for questions, or everything is clear. Great. So we dive into the statistical study with Dr. Eli. Oh, we have a break now? Oh, excuse me. So we earned our break, right? So we have a health break for 30 minutes, right? So we have a health break, grab some coffee, and please, let's go back to this room in 30 minutes in order to dive into the statistical calculations.
Research, knowledge we share with pride for a world where health is on our side. Collaboration and science exploratory.
The Global Food Regulatory Science Society, GFOR's mission includes knowledge generation and dissemination, underpinning food regulatory decisions, in support of food control systems, Our interventions focus on promoting food regulatory scientific disciplines. Consistent reliance on food regulatory sciences enables robust food control programs, contributing to more resilient food systems and a safe, accessible, abundant and nutritious food supply.
Test 1, 2, 3. Testing 1. Testing 1. Testing 1. Testing 1. Testing 1, 2, 3. Test. Testing 1.
Good.
صباح الخير عن جديد. صباح الخير عن جديد. اوه طيب خلال هالجلسة رح نحكي عن شوية أرقام، وبعتذر من الأشخاص اللي ما بتحب الأرقام، بس ما في شك إنه بكل شيء عم نعمله لازم يكون في عنا أرقام تنعرف وين نحن وين لازم نصير. So in this part, we will be talking about the data analysis of the development for the ML. I would like to say that today's sessions are really a sequence that we need to understand in order to build our knowledge and improve our, let's say, capacity in how really we can achieve our goal, finally, to protect the consumer as the basic scope of our work. So in this session, we are going to define mainly statistically what is maximum level, or obviously their relevance to Codex standards, to understand the importance of occurrence data, as we said before, to identify data distribution types, and to apply statistical methods to analyze contaminant occurrence data, especially for what we call non-parametric approaches, to handle data challenges such as low sample size, left censored data below LOD and LOQ, as well as to evaluate and compare multiple data sets, and finally to recap by using what we call the 5-step process for statistically robust ML development. So this is our agenda for today, as I said, and we will start with a quote that I liked a lot. First of all, do you know this guy, Edward Deming? Any idea? Who's... So he's one of the quality gurus. He's a statistician, and obviously what he said is very interesting. He said that in God we trust, and all others must bring data. So data are facts that we need in order to understand and in order to, let's say, clarify our status. So I believe from this quote we can understand that it's not a let's say, option, it's a mandate, it's a must to be able to understand what's happening through facts and evidence, which is equal to data. So already we talked about the MLs, the maximum limit. which is a regulatory upper limit for contaminants in food or feed. So this is a definition that should be based on scientific data, good practices, and risk assessment. So in order to achieve a good, let's say, level of risk assessment, we need scientific data, good practices that will generate for us what we call the ML. Obviously, we rely on the occurrence data as the evidence-based. What do we mean by occurrence data? It's the data that is basically reflecting the concentration or the amount of a contaminant in a food. Okay, this is the occurrence data. And as we said before, the food that is as much as possible close to what we eat. Okay. Why statistical analysis is important? To ensure MLs are protective, realistic, and reflect real-world contamination patterns. I believe this sentence can summarize all what we want to take as filters in our data analysis. We should always think about this. How can we make the maximum limits protective, obviously, to consumers, realistic, and this is very important because we may go to underestimate or overestimate the contamination, as well as to reflect the real world contamination. And here, Dr. Amin explained deeply, when we talk about data, we need it as much as we can, real world data, reflecting what is really coming into our plate. Obviously, there is a lot of sources that can generate data that we can use in ML. I will not go through this again because we have already talked about it before. So if we want to introduce the statistical analysis of occurrence data, we can say that statistical analysis is essential for handling occurrence data sets in the development of the maximum levels for contaminant in food and feed. So we cannot generate maximum limits without statistical analysis, as well as that this will ensure that MLs are based on robust, scientifically sound data reflecting real-world contaminant levels. And we'll see some examples how the misanalysis of the data can lead to bad decision-making on the level of risk assessment. There is steps in analysis. Obviously, we started with what Dr. Amin mentioned, data extraction and cleaning, data cleaning. So those are the two first steps that we should follow. And today, in this session, we will be tackling the distribution assessment as well as the presentation of the results. And those results, as we said, will be sent to the electronic working groups for assessment in order to prepare the risk assessment results and share it with the risk managers. For sure that our aim is to apply those maximum limits at the global level. And this is a challenge, obviously, because the level of contamination is not the same all around the world, as well as the data quality is not the same all around the world. But we need to know that globality will ensure that MLs are relevant and effective across different regions and conditions. Imagine that you will specify one number that could be applied for all parts of the world. This is not really very obvious and easy to digest. So the expert working group, as we said, they will take those results and they will work on it for informed decision-making, and they are relying on the data that we can generate in order to finalize the establishment of the maximum limits for contaminant. So as we said before, we are now talking about only contaminant, not other types of substances. I always ask this question, why statistics save lives? And maybe, as we said, sometimes we don't like to work with numbers, but sometimes really statistics can help us to differentiate between what is true and what is wrong, what is real and what is fake. And obviously, the core message is that the robust MLs, maximum limits, will lead not only to consumer protection, but also to fair trade. Who agree with me on this message? Any? No? The others? Do you agree? If you agree, raise your hand. So who can tell me how can the ML ensure fair trade? Because consumer protection, I think, is obvious. But for fair trade, how can the maximum limit can ensure fair trade between countries? Okay, we'll have a standard limit. What else? Okay, so everyone will be treated in the same level for the trade. There is no discrepancy in the levels. What else? Standardized quality and safety, obviously. So let's always think about this. Maximum limits of contaminants, it's not only related to food safety, it's also related to the fair trade. As long as this maximum limit has been defined and developed on a robust scientific basis, it will lead obviously to what we call consumer protection and fair trade wings of the main concept of our work. So our work goal is to set science-based maximum limit to minimize, obviously, the health risk, and as we said, for fair trade. So this is why the main objective is to minimize health risk. This is why, according to the Codex guidance, MLs should be set at a level which is slightly higher than the normal range of variation in levels in food and feed. And this is what we call worst case scenario. So when we set the ML, we push it a little bit higher to be sure that all, let's say, the result will be inside this level or limit that we are setting up. And we'll see how. So let's say if we got a result of 12.3, we always round it up to 13 or even to 15 to be sure that we were able to protect all those factors that we said. Let's now start with after Dr. Amin presented the generation of data, the extraction and the cleaning, let's move now to the assessment of the distribution. I believe some of us know about this picture or this figure where we talk about how our data is distributed, okay? What we see in the center, this is what we call the bell curve normal distribution set. So as you can see, we have here the majority part of our data set, our data numbers are in this part, which is around the mean, the median, and mode. We have few results that are lower and also few results are higher. So it's a very symmetrical distribution showing a certain normal distribution of data. And when we talk about this situation, we are talking about what we call parametric situation, which is more related to a certain way of data analysis. So if your data set is normally distributed following this shape, you will be using a certain type of statistical analysis that will be different from the two other scenarios that you can see it, where the data is not symmetrical, but deviated or deviated to higher levels. So here you can see that mean is not anymore equal to median or mode, and there is a very low part of your data that have a certain low results, and the majority part of your data is going up to high results. So you have high results in your data set. And this situation, we call it skewed, is the situation, deviated situation, where you can see that we call it negatively skewed or left skewed. Why we call it left skewed? Because we follow the tail, this part where we have the minimum number of data set that are to the close to zero. And the other side, we have what we call positively skewed or even right skewed, where it's the opposite of this one. The major part of your data set is more close to zero, very low, and a small number of your data set is high in results. To make this explanation, because this is very important, easier, I would like to ask for any voluntary person who would like to join me on the stage. Who dare? There is a prize at the end. Yes, please. So we have three situations. We have normal distribution data, negatively skewed distribution data, and positively skewed distribution data. We'd like to have the microphone, please. You have one. Already you are. So I will give you three scenarios, and you will tell me which scenario is related to which situation. We have, first of all, aflatoxin levels in peanuts, fiber levels in whole wheat bread, and pH levels in pasteurized milk. So those are three scenarios. And I would like to ask you, from your point of view, which one is related to which scenario and why? Is the question clear? Okay.
I think that the aflatoxin level in peanuts is related to the symmetrical distribution.
So you are saying that aflatoxin level is related to the symmetrical level. Who agree? Who don't agree? Okay. Can you please tell us why you don't agree? If we can have the microphone, the second one.
I don't know. I thought that the pH levels in pasteurized milk was the middle one.
Okay. So the pasteurized milk is in the middle one. So you don't agree that aflatoxin level is in peanuts is in the symmetrical one?
I believe it's very hard to get an even distribution for something like this.
Okay. Do you agree? So let's come back. So let's start with the aflatoxin levels. Where you put the aflatoxin levels? Positively skewed or negatively skewed?
Positively.
Positively skewed. Why? Because the major samples results of aflatoxin level in peanuts should be close to zero. Otherwise, we will die all. Yes? And few of those samples are above, let's say, a certain level or more to the upper level. So if we come back to fiber levels in whole wheat bread,
The opposite. Should be negatively skewed.
negatively skewed, because when we talk about fiber in whole wheat, we are expecting to have high level of fiber, okay, and few samples that are not really rich in fiber. And finally, pH level in pasteurized milk.
It has to be
So
constant.
the major part of the samples will be in the center, and that's the result. Thank you.
Welcome.
So if we want to summarize this short, let's say, simulation, we can see that for each case, data generated will follow a certain distribution, okay? So we cannot say that we have always the same distribution of data according to this example. So if we focus on the last one, what we call positively skewed, right skewed, this is mainly what's happening with all types of contaminants. So all types of contaminants, we know that they follow the right skewed distribution, okay? So they follow this format of the situation, whereas we said the major part of our samples will be around a lower level and few part will be up to the higher level. Are you convinced for this? Is it okay? So coming back to what we said before, we should be okay with that when we talk about contaminants, contaminants cannot follow a normal bell-shaped symmetrical distribution. Okay? They, by nature, follow a positively skewed, right-skewed distribution. And as I said before, because contaminant will not follow the symmetrical distribution, we cannot apply parametric statistical test or assessment or a certain type of test. What we apply for this situation, and we will see it later on, we call it non-parametric statistical assessment. It means there is specific tool, statistical tool to be applied in our situation. Not all tools can work, and this is very important because when we understand the shape of the distribution of our data, we can know and we can be sure that we should follow a certain, let's say, type or protocols of data analysis. So we agree that contamination data distribution is often right-skewed. This is why parametric methods are not suitable because they need that the distribution should be normal, which is not the case, as you can see, and may underestimate high percentiles and may underestimate the real ML. So if you use parametric methods, you will be underestimating the real level that we should work on it. And here we will have bad decision because it's based on bad assessment. So the recommended approach is using the non-parametric methods, like what we call the empirical percentiles or fit a log normal distribution. We'll be talking about it later on. It means what? When you have a data set, okay, a series of data coming from occurrence data about your the contamination level in your product, we cannot use the normal mean, median, mode, and so on, because those are more related to normal distribution values. We need to use what we call percentile, which is more used when we have non-parametric methods. So to make the long story short, since data distribution of contamination in products is following a non-parametric shape or skewed shape, we need to use percentile instead of other methods in order to generate our MLs. Any question? Okay. So as we said, why not to use the mean or median? Because MLs must cover the upper end of contamination level, which is not really applicable for the non-normal distribution, because we need to be sure that we don't underestimate the real situation. This is an example why parametric method fails. So if I'm assessing the lead in spice, if I calculate the mean, it will be 0.8, for example, ppm, which is underestimating the risk. If I calculate the mean plus 2 standard deviation, it goes to 2.1. It's still missing extreme values. This is why I need to search for the percentile, which can capture the tail risk, which is related to the most critical part of my data set, and we'll see it now. So we use the percentile, mainly the 95 percentile. We'll talk about it in details, because this is the value below which 95% of the data fall. So this is the value that we can adopt as a good value to set our ML, not the mean or median or mode, since, as we said, our data set is not normally distributed, it's skewed or deviated. And in food safety, it helps to identify high-level consumers or high contamination levels if we are talking about contamination, important for exposure assessment. Because when you, as we said, we will do it every time. What is exposure assessment? Is equal to what? Occurrence times consumption. So if you lower your occurrence, you are lowering your exposure assessment and you are underestimating the risk. This is why you need an occurrence that is real, but in the same time that can cover up to 94% of the data to be sure that you are securing all types of possible scenarios. And then you will run your risk assessment to see if this level of exposure is risky or non-risky. So if we want to take this graph, which is, as we said, positively skewed graph, this is the tail where 90 to 95% of contamination data is here, the high level for contaminants. And most samples, the majority of the samples are or low or undetectable in contamination. And few have extreme contamination. And here I'm talking about this tail, Zanab, Zabatkun, that is really related to rejected from the market. And Dr. Amin will follow on this later on regarding how to calculate the rejection rate. So we can go up to 98% percentile, or we can go down to 95% percentile. And as you see here, here comes the hypothetical ML that we need to calculate. So how we calculated, obviously, I'm going to bring the two, the manual and the electronic way of calculation of 95th percentile. Let's say we have to measure a contaminant X in a matrix Y, and I got 20 samples of this product, and I measured the contaminant level. So I got, as you can see, the results. So in the sample number 1, I have 30 microgram per kilogram, and so on. The first step I should do is to put it in order, okay? Ascending order, from the lowest up to the highest value. Then I use the percentile position formula, which is percentile is equal to N, which is the total number of the data set, plus 1 over 100 times 95 if I want to calculate the 95th percentile, or 98 if I want to calculate the 98th percentile. And in this case, it will lead me to this value of 19.95. What does it mean? It means that my percentile will be between the 19th and the 20th value in the sorted list. So this is the position of my 95th percentile value, okay? So here it's giving me that my percentile, which is the 95th percentile, will be between the 19th and the 20th values. So if I come back to my list, sorted list, the 19th value was the 40, and the 20 value is 41. Okay, so if I want to calculate the 95th percentile, I will go for this formula without going more in details, because nowadays we use electronic way, and it will lead to a 40.95 microgram per kilogram as the 95th percentile. And as we said, based on Codex guidance, and in order to go to the worst case scenario, we round up this value or to 41, or even we can go to 45. It depends on our assessment and our study at this level. And let's say that percentiles help avoid underestimating risks. As we said, it's used by all types of bodies who works on it as the one that is really used to reflect, first of all, realistic, but also worst case scenarios. Okay, Any question? When there is no question, it could be in the two. Yes. But we need to calculate the mean. Yeah, we can do it. I didn't, but we can have the result after and we can compare, obviously. But obviously, it will not, it will be somewhere in the center. So 28, let's say 29, okay? So you are pushing the worst case scenario in a lower case scenario, which is not good because you need to check what is the maximum exposure that we are exposed based on the contaminant. Okay. For those who are expert in Excel, there is a simple Excel equation that you can use to calculate the percentile. So if you have a set of data, you put equal percentile point EXC, and you select the row of your data and comma 0.25 if you want to use the 25th percentile, and you got directly, electronically, the calculation of the 29th percentile. Let's move now to answer this question. What is the minimum number of data points to obtain percentiles values in order to generate MLs? How many data set do we need? How many data points do we need in order to generate the 29th or the percentiles in general? Any idea? 3? 20? مين بيزيد؟ 60? 100 because it's percentile? Okay. 1,000, John? High number. Unlimited number. As long, okay. Any other? Okay. Obviously, there is an answer to this question, and it's based on a complicated formula that will be used in order to generate the exact number of samples to be tested in order to be able to generate. And what we call exact number is a minimum number of data set. First of all, let's say that the number of samples that we need depends on the confidence level that we would like to work on, which is mainly in food safety as used as 95%. It means I want to be sure that my result is true up to 95%, and I accept an error of 5%. This is commonly used at level of confidence. This is first. Second, as we said, in order to specify the number of samples that we want to test, we need to specify the percentile that we would like to work on. And as we said, 95th percentile is the most usable one. So it's easy to memorize this because we are still in the 95th percentile, 95%. So we want to know the confidence level, and we want to know the percentile level that we want to work on. And let's make it easy. Those are the levels that are mostly adopted worldwide. And this will generate a minimum of 59 data points that is necessary as a number to estimate the 29th percentile with 95% confidence, ensuring statistical robustness. So 95%, 95th percentile will lead to a minimum number of 59 data points that will allow me to start to analyze and search for my value for ML. And obviously, if I have less data points, it's not the end of the world. There is other tools to be used in order to generate those numbers. But obviously, in normal situation, and what we need to know is mainly at this level. And just to show you other scenarios, so as you can see, the minimum number of data points is based on the level of percentile and the level of confidence that we would like to do. Let's have a look, first of all, on the first case, the option 1. For a confidence level of 95% and a 95th percentile to be calculated, as we said, we need 59 data points. If I increase my confidence level from 95% to 99%, so it's really close to 100%, obviously the number of data points will be 90, so almost the double. So I need to double my number of samples if I want to go up to 99% of confidence level. And as you can see, the more I go in the percentile level, the number of samples needed will be higher. Obviously, the same here. How about if I don't have a confidence level to be estimated? Obviously, in this case, numbers will increase and increase up to 400 data set to be used in order to generate a let's say, ML based on the 95th percentile and this. So this is why when we are talking about 59 data points is needed, which is the minimum number that we need based on this, let's say, condition, 95th percentile and 95% of confidence level. If we don't have 59, what should we do? So to handle data set with lower number of data points, in general, when the JECFA evaluation suggests that a health risk from exposure to a contaminant is significant, we can accept a smaller number of data points than the minimum number that we mentioned here. So between tackling a significant health risk, we can compromise with a lower number of data points. So when an ML is urgently needed for consumer health protection, when we have an emerging urgent situation, the electronic working group tasked with recommending MLs should consider recommending to the CCF the development of MLs, even if the number of the data points available is not too high, it's a small number. And if sufficient data later on become available in the future, we can revise the ML that we put it and we can update it accordingly. Obviously, if there is no immediate health risk, we should wait until we got additional data calls to fulfill the minimum number of data set before we launch our assessment. Okay? So safety first. What about left censored data in data set? Any idea what do we mean by left censored data? Yes? What do we mean by left censored data? Most of the results are high, are positive. Not. Yes, that's it. So left censored data is more about non-quantifiable data, okay? So it's values that are or below the LOD or below the LOQ. So we don't have numbers in our data set when the major part of our data set is not a quantifiable numbers. So we just put less than 1.0 or less than our ND not detectable. Okay, this is what we call the left censored data. And in this case, obviously, we need to have statistical analysis, but we are limited because I need number. I cannot put less than. I need a certain number. In this case, obviously, we cannot ignore this data set. We cannot say, since we don't have real numbers, we will put it aside. No, this will bias the analysis. The substitution methods are employed to assign value for these data points. So it means what? It means whenever you don't have a quantifiable data set, so it's an ND not detectable or less than 1.0, we need to transform this descriptive result into a quantitative result, into a value that we should insert it instead of this value. So this is what we call substitution method. We are substituting a qualitative result, not detectable less than, to quantitative result. And in this case, the common substitution scenarios are the lower bound, LB, the middle bound, MB, or the upper bound, UB, which is more related to the LOQ. That I'm going to explain it now. So the first scenario is lower bound scenario. What do we mean by this? In this scenario, results below the LOQ are replaced by 0. So every time you have a result less than LOQ, you will transform it into 0, or by the LOD if the LOD is known. Obviously, if the result is higher than the LOD are replaced by here the 0. This is the scenario 2 is the upper bound scenario. Result below the LOQ are replaced by the reported LOQ value. So I moved from less than LOQ to the LOQ. Okay, I changed from qualitative less than to the minimum value of the LOQ. And the third scenario, which is what we call the middle bound scenario, a point estimate between two extreme scenarios, and this is the case, assigning a value of LOQ over 2. So the half of the LOQ, or square root of the LOQ, or LOQ plus LOD over 2, if the LOD is known for the analytical results below the reported LOQ. And let's say also the most usable situation is to use LOQ over 2 is the most widely used in dietary exposure assessment. So obviously we don't have enough time to go in deep in this, but you will be working on something that is similar during the breakout sessions. Let's say that no data is not usable. Even if the data is not quantifiable, we can change it to a quantifiable using one of those, obviously, scenarios. So for each of these scenarios, if the LOQ is not reported and only the LOD is reported, so we use the LOD as an alternative. Okay, so to sum up, if my data set is a left-censored data set, it means it includes a lot of less than to a certain value, not detectable, and so on. There is 3 scenarios to follow. You can choose one of. Basically, the middle bound scenario is a point estimate between the 2 extremes, and in which you can or use LOQ over 2, where there is no value, so you substitute it with this, or the other situations. Attention. If and when we have a set of data that are too close to each other and are also close to the reported LOQ, it means when your data set includes values that are homogeneous, so too close to each other, and they are all close to the LOQ, the limit of quantification. In this case, developing an ML may be unnecessary unless the contamination or the contaminant is highly toxic. So the electronic working group can make a recommendation to CCCF on the appropriateness of an ML in this situation. So there is some cases where we don't need to set an ML because our data and the occurrence data show us that there is a certain consistency in the values. They are really close, and all values tend to be near the LOQ. So there is no need to really make this case, but obviously this should be assessed case by case without any, let's say, previous assumption on this. Okay, we move now to talk about combining and comparing data sets, multiple data sets. We know, obviously, that we want to have a global applicability of Codex ML. And when we say global applicability, it means what? It means that we need to get information, data set from different countries, okay? And not from one country as it is. This global applicability needs to have data from regional and from areas where we can have a certain variation. And those data sets may vary by region or years, where we need to compare the data set. What do we mean by this? Simple example. If you want to generate a combined data set, including data coming from different countries, you cannot do it before verifying if those data sets are similar, because you cannot mix oil and water. So if I have data set coming from, let's say, from Oman, and data set coming from Qatar, can I say directly I can put all together and generate 1 ml based on this data set? No, because maybe there is what we call a statistical difference, significant difference between the two data sets. And when the data sets are not statistically similar, I cannot combine the data set. Okay, so before you combine any two data sets coming from two countries, you should be sure that those data sets are statistically not different. Is it clear, this idea? And I think it's obvious for everyone. I cannot assume that all data sets are similar. And if I want to make what we call a multiple data set, I need, first of all, as a prerequisite, to verify that my data set is really statistically similar from the different components. Yes? No, when you generate your data from country A and country B, before you combine the two for global assessment of ML, you should verify that those data sets are comparable, are similar statistically. Okay, so I'm not talking about they have the same numbers. I'm talking about that you can combine. So you need to verify that the two are water to mix or the two are oil to mix. But if you find that one is water and one is oil, you cannot mix it together. So there is a prerequisite before we combine several data sets to use statistical analysis in order to achieve this homogeneity in the final global data set. And in order to do this, there is statistical tests that we use. Those tests are, I will bring you back to the first part of my presentation. Those tests are related to the shape of the distribution. So if your data is normally distributed, you use parametric test. And if your data, as our case, is not normally distributed, is skewed, is deviated, okay, is the contaminant are positively skewed or negatively skewed? The data set positively. Okay, so why? Because in this case, we have the major part of our data set is close to low, and this low part of the data set is close to high. In this case, also, not to complicate things, we use non-parametric tests, okay? Such as Mann-Whitney test, excuse me. Mann-Whitney test, if I have to compare two data sets, one from Qatar and one from, let's say, Oman, or Kruskal-Wallis H test, which is a test used if you want to compare more than two data sets. Okay, and this will help to assess distribution similarities. It means it will help me to say, can I combine, or I need to assess it individually? Do you agree? And this is basically based on for those who are familiar with the hypothesis, the null hypothesis, which is the hypothesis 0, stating that all data sets are coming from the same population or they are similar. Okay, so if I have two data sets, I cannot merge it directly. First of all, I need to check their similarity, if they are similar, or if I am allowed to mix. And how can I do it? By statistical tests like the Mann-Whitney test, if I have two data sets, or the Kruskal-Wallis test that I can use if I have more than two data sets. And in this case, I check the p-value of the test, okay? And if the p-value is lower than 0.05, I can refuse the null hypothesis. It means the data set are different. And if this value is higher than 0.05, I can accept or retain the null hypothesis, stating that there is no statistical difference between the two data sets, so I can combine. In order to make it simpler, because obviously we are not here to go in details on this, I will take an example of checking aflatoxin in peanuts. I have two data sets, okay? 40 inputs coming from Nigeria and 40 inputs coming from Argentina. I have, as you can see, the country and the aflatoxin level, total aflatoxin in ppb, as well as the sampling date and the sampling source. I have a set for Nigeria and later on a set for Argentina. I will show you as a demonstration how can we do this using a software, statistical software named SPSS. So just as the demonstration to show you how can I answer my question. Can I combine the two data sets? Yes or no? This is our object. So as I said, we have here the data set. As you can see, we have Nigeria data set and then Argentina, okay? And you have a data point for each one. So what should I do? I have a data set showing a country, the values, the sampling date, and the sampling source. Some samples were taken from open market, from warehouse, from rural farm, and so on. So I go to analyze, I go to non-parametric test, as we said, because we know that contamination follow what we call the non-parametric type. And here, if it's not clear, I can use the other. No. I think this is better because, okay. So I go to analyze non-parametric test, and I go to independent samples because I have two samples to work on. And here I will choose to test what? I want to see for aflatoxin level, if the levels of aflatoxin are, let's say, can be comparable between the two countries. So I take the country and I put it as groups, as if I am saying what? I'm saying I want you as a software to compare the two countries regarding the aflatoxin level, trying to see if I can merge or not my two data sets. But before I do this, I need to run a check before this. Who can tell me what should I check before I run the test? What should I check in my data set? So I close this. What should I check? Yes? Confidence data. level, no. Huh? Outliers, as Dr. Amin mentioned, my data set should be cleaned and verified that I can use it, because outliers, as Dr. Amin mentioned, will bias the assessment itself. Okay, so before I go in this, I need to see if my data set includes outlier or not. Okay, so rapidly to show you how we can do it and to apply what Dr. Amin mentioned, we go to analyze to descriptive statistic explore. Okay, excuse me. Oh. I will choose my aflatoxin level, okay, and I will say okay. And I will check the result by looking at the box plot, this one. Do we have an outlier, yes or no? Do you see the outlier? Where is the outlier? Number 12. So this assessment is saying to me that pay attention, you have one value that could bias your analysis, that is number 12. And this is very important. In this case, what I should do, I should go back to my data set and look at the number 12, which is this value. So the sample number NG012, Nigeria, which is 29, is considered as an outlier. So I should remove it. Otherwise, it will affect, obviously, my assessment. So let's say, because I put it just for this, let's say it's 22, it's not 29, because this is what the case. So let's come back. So after cleaning my data set, okay, by removing this situation, again, I go and analyze my, as we said, my data set by including the aflatoxin level in the test field and the country in the group field, and I will say run. And here comes the result. If you look at the result, you can see that the test that we conducted is the Mann-Whitney U test, okay, showing a significance, or the p-value is 0.58. This value is higher than 0.05. It means the null hypothesis was retained. We keep it. And the null hypothesis say that there is no statistical difference between the two data sets, so I can merge and generate my ML. So in this case, I can, as we said, be sure statistically that my two data sets are statistically similar. So I'm allowed now to merge those two sets and generate my ML accordingly. Obviously, in this presentation, also you can see the nice distribution of my results accordingly, and I can have the different data set results statistical without further discussion on this. Okay, so it was just an example to say that obviously whenever you have two data set or even more, because Kruskal-Wallis test can be used for even more than two, we are sure that we can use or not to merge between, to combine the different, let's say, data set accordingly. So this is an example when you have individual data set and combined data set, and those data set coming from statistically same, let's say, sources. So as you can see, it's relevant and it's more or less the same input. To speed up and to summarize also, obviously, when your data sets are not comparable, when the statistical results show you that you are not allowed to, let's say, to merge, you are obliged, obviously, to run your analysis individually, each data set alone. Finally, as we said, just to recap what we mentioned, the statistical analysis steps are the following. Clean and verify the data set, what we have learned with Dr. Amin and what I show you in the checking of the outlier, among others. Assess the distribution of the data to be sure that it's not normally distributed, it's skewed positively. Use appropriate statistical method like this one, or obviously others, to generate and estimate the percentiles. And we agreed on the 95th percentile to cover the status of worst case scenario, and obviously round it up to a reasonable ML. So as we mentioned before. So as a take-home messages, based on all what we mentioned, to develop MLs using statistically robust data set, prioritizing, minimum data requirement and appropriate distribution assessment. So we need to have a minimum number of 59, and we need to be sure that the distribution is appropriate for the data set. Obviously, statistical tests should be used. We cannot do it just by calculating mean, median, and so on, because it will underestimate the real exposure. Sometimes we need to go case by case to decide how to, let's say, to develop the MLs, as we said. Obviously, we should use transparent documentation practice by using softwares, data results, obviously, this is very important. And finally, we should always think about the skewed data. That is the case of contaminant by applying the non-parametric test and all other methods. My last message is the following. I asked the AI to generate for me a picture, okay, that summarizes all what we discussed. He gave me this funny one. So the first one is asking, I think this looks safe enough. And the other one is saying, let's ask the 29th percentile. But there is an error in this picture. Who can tell me where the error? The graph. It's a normal distribution, but in our case, it should be skewed. So pay attention to AI, because even AI can be wrong. Thank you.
Thank you, Dr. Eli. Didn't we enjoy the presentation by Dr. Eli? So another round of applause, if you may. So we still have 2 steps, right? For setting our ML. Who can tell me what is the next step now? So we have our data set ready, we extracted, we prepared, we did all the statistical preparations, and now? Yes, now we have to dive into really setting our ML, okay? Through 2 steps. We still have 2 steps. I will be presenting the first one quickly, and then Dr. Karima will continue with the most important one. But what are the 2 steps? Because always when setting an ML, we have to compromise between fair trade and good protection level. So let's start by considering the fair trade and the economical impact. Through what? What we will be estimating in order to account for that? The rejection rates, right? So now we will start by properly discussing the setting of our ML. In order for us to start this discussion, we should set or agree on what we call hypothetical MLs, right? We should work on some values. We will start by stating or agreeing on what are the possible MLs that could be appropriate. These MLs are called hypothetical MLs. Then, using those hypothetical MLs, which are several, right? I need to do several tests in order then to agree on one, right? So I have a strategy, I have a procedure in order to set those hypothetical MLs, Then I will be calculating the rejection rate. And now I will explain to you what do we exactly mean by the rejection rates, which is a very simple concept. Then using also those hypothetical MLs, I will estimate the intake. Okay. And then I will look at the results and I will try to compromise. And this is based on what is called the ALARA principle. And then I will take my decision on the adoption of this ML in the way that is as low as reasonably achievable in order to protect enough, but also not to disturb the trade, right? So that's our step now. Okay, so in order to start properly our discussion, we have to first estimate our hypothetical MLs. So what are hypothetical MLs? Now, based on the discussion with Dr. Eli, we will be able to set few candidates of MLs, right? I have to have candidates for possible MLs, and I will try to do my procedure on all these different candidates and compare to agree on one of these MLs. So hopefully after this module, we will be able to understand the approach used to set or to estimate those hypothetical MLs, perform calculations in order to determine the rejection rates, and then we will discuss the calculations related to the intake or the exposure. So what are the candidate hypothetical MLs? A candidate value for an ML is identified from a high percentile values, usually around or slightly higher than the 95th percentile of the targeted data set. So I have my data set ready. I performed my statistical analysis, and now I need to propose MLs in order to work on. The first proposal that is logical to do is to take the 95th percentile as a candidate for my ML, or value a bit higher than the 95th percentile as a candidate ML on which we will be working, and now you will tell me why. The precision of the current analytical method and significant figures of the analytical results should be taken into consideration when I propose an ML. Do I propose my ML as a value of 10, 15, 5, or as a value of 15.1, 5.2, or as a value of 0.62, 0.65, 0.74, or 0.5, 0.6, 0.7? What do you think and why? I'm still thinking here about the candidate ML, the hypothetical MLs, okay? I have a data set, and I have my 95th percentile, and I want to start proposing MLs. Before agreeing on the hypothetical MLs, the significant digits or figures I will be taking into consideration. What do you think about that? When I'm proposing hypothetical MLs, I will be proposing around value like 5, 10, 15, 6, 7, 8, or I will be taking 5.5, 6.5. So the significant digits, do you have an idea? It could be based on what? It could be based on the contaminant itself, the analytical method used in order to evaluate it, right? But we have the tendency of rounding the values, as Dr. Eli said, in order to be always in the upper value and the worst case scenario. And rounding the value is easier to verify for compliance. Do we agree on that? You can disagree and tell me why. Okay, so we're discussing here the reflection on setting those hypothetical MLs. So the precision of the current analytical method and the accuracy of the analytical method should be taken into consideration, or what we call the significant figure in the analytical result should be taken into consideration when proposing candidate MLs. So numerical values also for MLs should preferably be regular figures in a geometrical scale. So for example, 0.01, 0.02, 0.05, or 1, 2, 5, 5, 10, 15. That's normally the candidate hypothetical MLs. When we start this process, I want to have several hypothetical MLs, preferably more than 2 hypothetical MLs to work with or to work on. And normally we have more than 2. So we could have 3 candidates with the breakout rooms, you will see situations where we will be testing for 4 hypothetical MLs candidates. So we need to have several options in order for us at the end to agree on one. Once this numerical candidate value of an ML has been determined, which we said could be the 95th percentile, could someone tell me why the 95th percentile is the candidate to start with for a hypothetical ML? Any idea? I have my distribution, and now I want to set my ML. Why the 95th percentile value is the first obvious and logical candidate for an ML? Any idea? Let's use the microphone, please, because that's the most important discussion we will be having here. I'm not saying that then I will be adopting this ML, but that's the first obvious candidate. Okay?
Because of the confidence level we chose, it was 95%.
Okay, that's not exactly the case, but it's a good start of the reflection. But let's take into consideration the idea, the definition of the percentile, as Dr. Eli explained to us. Let's remind ourselves, what is the definition of the 95th percentile? What does it mean?
It's the results that are below.
Yeah, the value,
the value
below which we have.
Yes, يعني, to express it, it's 95% of the result. يعني, if you take the higher result, it's the 95% under the highest result.
Okay, so it's the value under which I have 95% of the results of my data set. Okay, and above which I have 5% of the results of my data set. Okay, remember this information now in the following slides when we'll be discussing the rejection rate. Okay, let's keep that in mind, and then you will answer us why it's the obvious first choice for setting an ML. Okay, so below which I have 95% of the data points, and above it, I have 5% of the data points. So, but for now, let's agree on the fact that the 95th percentile or a value around it is the first obvious candidate and logical candidate to set an ML. Then I need more choices to work with. So the next higher and lower value can also be suggested as hypothetical MLs. I could consider the 98th percentile, the 97th percentile as other candidates for MLs to be tested. For example, for a candidate ML of 0.5 milligram per kilogram, additional hypothetical MLs could be 0.4, 0.6, for example. Or if I have one, I could go for 2, 3, and 4 and test for those MLs. In the case of revising, I have an ML, and now I'm trying to revise the ML. I should consider the already adopted ML as a candidate again. So always I should consider this existing ML as one of the hypothetical MLs. Further values, as we said, could be obtained from the high percentile values, normally 95th, 97th, or 98th percentile value. Now, let's review that. The first step, I have my data set. I prepared it. I have to agree on hypothetical MLs, 2 values, 3 values, 4 values, on which now I will start my calculations. Any questions till now? We didn't answer yet why the 95th percentile is the most obvious one. Then I set my hypothetical MLs. The first obvious step to do is to start calculating what we call the rejection rates in percent. What are the rejection rates? And they are indicative of what? Very simple formula. The rejection rate in percent is the number of data points which are above the hypothetical ML I'm working on now, divided by the total number of data points times 100. شو بيعني هيدا exactly? Who can explain to us? From a practical perspective. Yes, Lama. From a practical perspective, what is a rejection rate? Amazing, excellent. And now this number corresponds to what? To a food commodity, right? My data point, my data result is representative of a food commodity. So when I set the hypothetical ML, all data points above the ML are indicative of potential commodities that will be rejected from my trade stream. Do we agree? So calculating the percentage of a rejection rate is the estimation or the evaluation of the economical impact of adopting this ML. Are we agreeing on that? So that's, remember always, the trade part and the safety part. So now I'm speaking about the trade part. We cannot disturb the trade stream. We have to take into consideration food security issues and the trade issues and economical issues. I cannot adopt an ML after which I will be blocking, rejecting, considering non-compliant 25% or 30% of the commodities traded. مقبول هذا الشيء؟ Okay, I will limit my discussion now on that. Then with Dr. Karima, we can discuss the part related to the exposure and intake, okay? Now, what do you think could be an acceptable rejection rate? Our all-time discussion. What do you think? 0%? Oh, let's start discussing 0%. What do you think? If I'm saying that my excellent situation, if my rejection rate is 0, am I applying an ML? I'm not applying an ML. So that's the exact situation where no ML is applied. Okay? Then I'm starting to applying MLs, and values of these MLs of my hypothetical MLs are decreasing. Okay? So I'm applying an ML of 2, then an ML, potential ML of 1. What do you think the rejection rate will increase or decrease, and why? And take the microphone. So I'm still studying several hypothetical MLs. I'm applying those MLs and I'm calculating the rejection rate. Again, شو هو rejection rate? The number of data points or commodities that will be rejected out of the stream. Now, if I have an ML of 5, then an ML of 4, 3, 2, 1, what will happen to my rejection rate if I decrease my ML?
If I decrease my...
Think it out for a second. Think it out for a second. I'm adopting lower MLs. I will be rejecting more data points or less? More data points. So I will be rejecting more, which is normal, right? I'm being more strict. I'm applying more strict MLs, so I'll be rejecting more. Now, let's go back to our discussion. What might be for you an acceptable rejection rate? So Professor Sam started by saying 0, and we had our discussion. No. Now, what do you think? 10, 20, 30? Amazing. That's an amazing idea. So I have to take into consideration, can I reject 10? Can I reject 20? Or what? Okay. Yes, Professor Sam, any other idea? Health and food security and food security issues, okay? So now you see this interesting discussion. It's always about that in Codex. The CCCF, to give you the answer, the CCCF, as a management decision, they decided to accept maximum 5%. They will not admit more rejections above 5%. Okay, now who can answer my first question? Why the 95th percentile is the most obvious choice of my ML? Because what is the definition of 95th percentile? It's the value above which I have 5%. So I'm rejecting 5%. Right? Okay? It doesn't mean that when they will be adopting their ML, it will be this value. But that's the most logical, obvious starting point. That's it. Yes. Yes. Excellent. Let's repeat it, okay? So it's a decision they took. within CCCF. Perhaps in other situations, you will take another, you will have another recommendation. Within the proceedings of CCCF, the Committee on Contaminants in Food, ضمن هذه اللجنة قرروا إنه يلي بنسبهم ما بيقدروا يقبلوا rejection أكثر من 5%. Otherwise, they consider إنه it will disturb the fair trade. That's it. It was a policy decision. Okay? اعتبروا إنه if I'm rejecting 10%, it's too much. It will disturb the stream of trade of commodities. That's it. Okay? We're still discussing the rejection rate here. بعد ما عم نعمل اللينك بين rejection rate والprotective. Good? Okay? So that's a decision. Yes.
I understand if it's maximum of 5%, so it would be 5 or lower.
Or lower. Yeah.
Never higher.
Yes. They will not admit higher.
Okay.
يعني any hypothetical ML, when we calculate our rejection rates, giving rejection rates of 7%, 10%, 8% will not be considered. Okay? Then, in some situations, let's say I will be brought to accept, for example, 5.5%, but that will be a risk management decision taken. Absolutely. So that's exactly our exercise, what we'll be doing, okay? But the concept, the spirit of it, we agree on that? Amazing. That's the idea of the rejection rates, okay? So, some assumptions, samples, we're assuming that, we are even taking some assumptions here. We're assuming that samples that exceed the hypothetical ML are all excluded from the market with 100% probability of enforcement, which is not the case, right? When you enforce an ML, do you have 100% enforcement? No, you will always have some samples skipping the control system. But here, when I'm having this discussion with you, we are assuming that 100% of data points or of samples traded above the ML are removed from the stream. That's an assumption. To assess the impact on international trade of the commodity, the global data set should be used. We had this discussion. And if necessary, data sets for each region. But do you remember the reason where normally we have to consider the global data set, data points coming from all countries. But I might consider particular data sets for few regions in case they have really different occurrence. If they have a critically, statistically different occurrence, perhaps I might consider that their situation individually. Otherwise, if I adopt an ML without considering their situation, they will have plenty of products rejected from the stream. But I need to prove that. I need to have a clear proof why I am considering the global data set and the regional data set. Okay, you will have this discussion with Dr. Karima in the breakout room. For contaminants known to have large annual variation and concentration, the rejection rate should be calculated for the data set of each year. نفس المبدأ. The geographical consideration and the time consideration, and I can have some tests depending on particular countries or particular years. So this will be defined by the electronic working. Now, obviously, you deduced that it's a very easy calculation, okay? So simply, you can look at it visually. If I have the distribution, you can look at it in your Excel distribution, or if you have any software you're using, a very simple thing. It's just the number of data points above a certain value. This number divided by the total number of your data set times 100. That's it. So if we have this distribution, which is a proper distribution for the case of contaminants, right? We had our discussion with Dr. Eli. So that's the histogram distribution of my data set, for example. I took it like hypothetically. And let's say we are studying a hypothetical ML of 1 milligram per kilogram. What will be the rejection rate? What do you think? Do this very simple calculation. How many number of data points are above 1? Okay, these are the ranges of the values here for this histogram. So I have 5. So the calculation will be 5 divided by the total number if you sum all these numbers times 100. That's it. Okay? Or you will do it using Excel or in a very simple way. So the calculations for rejection rates are nothing to consider, okay? The basic type of calculation. So that's it. Hypothetical MLs can be estimated using available data, occurrence data, to explore the impact of potential regulatory limit. And we spoke here on the economical part, the trade part. Calculating rejection rates provide insights into the practical consequences of setting specific MLs. We do not want to disturb our international trade stream in an unacceptable way. These tools support evidence-based decision-making by balancing food safety objectives with trade and feasibility. So we spoke here about trade and feasibility, and here I invite Dr. Karima to speak to us about the safety objectives when setting those MLs. Thank you, everyone.
Thank you very much, Amin. I am pleased to come back here in this stage and for giving you this final presentation. فكما لاحظتم خلال هذا الوركشوب حاولنا أن نعطي لكم نظرة شاملة حول كل التطبيقات الهامة التي يمكن من خلالها أن نستثمر البيانات، وبين لكم أن البيانات لها دور كبير في كل هذه التطبيقات. والآن سوف أقدم لكم آخر حلقة يمكن استعمالها أو تستعمل بالأساس خلال ال stepwise procedure أو يعني كل التطبيقات التي تستعمل من طرف الدستور الغذائي. وبالنسبة لهذا التطبيق هو خاصة يستعمل لاتخاذ القرار فيما يخص تحديد الحدود القصوى. فبالنسبة لبعض الملوثات وفي بعض المواد الغذائية فقد قامت الكودكس باتخاذ بعض القرارات في إمكانية استعمال بعض الميثودولوجيا تمكن من باتخاذ الحدود القصوى الملائمة. فأنا يعني أسطر على كلمة ملائمة لأن بالنسبة للكودكس نحن في صدد اتخاذ يعني أو تحديد حدود قصوى عالمية، وبالتالي يجب مراعاة بعض العوامل. من بين العوامل هي السيفتي أول شيء، يعني سلامة الغذاء. فهذا أول شيء يعتبر في يعني اتخاذ القرار المتعلق بالحدود القصوى أو كل المعايير الصحية. وثانياً أن لا تكون هناك عراقل بالنسبة للتبادلات التجارية، وهذا هو ما تحدث عنه رفيقي أمين باعتبار الكالكوليشن أو rejection rate الذي يعطي لنا نظرة يعني precise idea حول كل يعني السلع التي سوف يتم يعني to reject them for trade إذا قمنا باعتماد الحدود القصوى. فالتطبيق الذي سوف أتحدث عنه هو أو الميثودولوجيا سوف تمكننا باستعمال الطريقة التي تحدث عنها في التقديم الأول، أي هو تقييم التعرض الناجم عن الغذاء. سوف نستعمل هذا الفورمولا ونقوم باستعمالها لدراسة مدى تأثير الحدود القصوى المعتبرة أو hypothetical MLs، مدى تأثيرها على الانتيك أي الجرعة المقدمة من الغذاء بما يخص الأخطار. فقبل ذلك بما أنه هو التقديم الأخير سوف أقف شيئا ما لكي أذكركم بكل المراحل التي أشار إليها بروفيسور سامويل، ولكن كذلك كل يعني العروض التي قدمت. فالكودكس تعتمد بالأساس على منهاجية يعني متكاملة. It's a really structured process for the establishment of safety standard. عند يعني في البداية فنعتمد على كل التوصيات المقدمة من طرف الهيئات التي تقوم بتقييم المخاطر والمعتمدة من طرف الكودكس. ورأينا أن هذه الهيئات هي جيكفا بالأساس وGMPR إلى غير ذلك من المؤسسات الأخرى التي تقوم بتقييم المخاطر. وهذه الهيئات تقدم لنا توصيات على شكل health-based guidance value, safe levels, toxicological reference values، وكل هذه المعطيات تستعمل في تحديد الحدود القصوى. فهي بالأساس هي الحلقة الأولى التي تعطينا نظرة أولية حول إذا كان هناك مشاكل أو مخاطر مرتبطة بالغذاء. بعد ذلك إذا في بعض الأحيان تستند كذلك الكودكس على أعمال working group Codex working group. فخلال هذه المجموعات العمل يتم من خلالها مناقشة إمكانية تحديد حدود قصوى، وهذه الحدود القصوى تعتمد على منهجية علمية. فهناك يعني تطبيقات تم اعتبارها واعتمادها من طرف الكودكس لتمكن من اتخاذ القرارات الملائمة، وباعتبار يعني بعض التطبيقات التي سوف أشير إليها الآن. بالنسبة إلى بعض الملوثات التي يعني جيكفا أو الهيئات لم تقر أو لم تحدد حدود safe level إذا صح يعني التعبير، فبالتالي فالمنهجية المتبعة سوف تكون مختلفة بالنسبة لهذه الملوثات. فنستعمل ARARA principles as low as reasonably achievable وكذلك rejection rate. فأنا بالنسبة لهذا التقديم سوف I will focus on the impact of MLs for the reduction of intake exposure. So in this talk, I will outline this methodology for conducting primary exposure calculation of effects of ML on the reduction of the dietary exposure. And I will demonstrate how this calculation can inform Codex deliberations. This deliberation normally is conducted within the electronic working group. And to share a simplified case study using hypothetical MLs to highlight practical applications. So this work supports improved data collection strategies and stronger scientific justifications in Codex discussions, and also enhanced regional participation in the standard setting process by using all the data provided by all the countries. So the key component of this process is the primary calculation of the potential impact of hypothetical maximum level on dietary exposure to specify contaminants for targeted commodities. The methodology is designed to estimate how different ML scenario may influence overall dietary exposure levels, thereby aiding in the assessment of risk reduction benefits. As I mentioned in my previous talk, we have in the first hand the risks, and we should have benefits when we are establishing MLs. So we try to balance all these two parameters. The approach typically involves the use of food consumption data and occurrence data. We use these parameters to conduct dietary exposure assessment. And after we also do the same calculation by considering all the hypothetical ML that was mentioned by Amin in its presentation. These calculations serve as a screening tool to inform whether proposed ML could effectively reduce exposure. When we establish our hypothetical ML, we will try to use them as an input in our calculation for dietary exposure assessment, and we will see if this exposure will help us. We will have a reduction of the intake, and we compare it with all the MLs considered during this calculation. So what are the benefits of this methodology? So first, we assess whether proposed standards are protective of public health. We talk about the intake. So we will see if the ML by using the ML in the calculation of the intake, it will provide us a reduction of this intake. And also to adapt international guidance to local food consumption patterns and contaminant occurrence. We have as a benefits to support the development of science-based food safety standards that reflect local environmental and dietary realities while aligning with Codex principles. And it supports the application of ARARA principles. As I said, in some cases, we don't have safe level, so we have to apply this methodology. We should have maximum level to establish these maximum levels for those commodities, considering these hazards, for example. The example is the lead. if we considered lead, we don't have the safe level. So we should apply ALARA principle to establish our limits. Here in this slide, just I want to show you some examples. During this is F18, this methodology was applied in different work done by the electronic working groups. And it was applied when for the establishment of maximum level for lead in certain food categories. Also in the analysis of the occurrence data of lead in spice mixtures, and also for the analysis of occurrence data on aflatoxins in cereals. If you come back and you look on the reports of the electronic working group, you will find that this methodology was applied, and it was the basis for the establishment of maximum levels. And now I want just to provide you a general concept of this methodology. First, we have to calculate, or we have to apply the methodology of dietary exposure assessment to have an idea about the current dietary exposure. And after that, we can do the same calculation, but with using the mLs as an input. And after that, we can by having all these results, we can use them to calculate the intake reduction under the application of mLs. And then we can have as questions, and we should answer to some questions. For example, is the current exposure is close to or exceeding the toxicological reference value? Does the proposed mL significantly reduce health risk? And what are the new mLs that we can apply for this commodity and regarding the hazard that you are considering in our calculation? So the first step, if you remember the methodology that I explained you to conduct dietary exposure assessment, first of all, we have to define our context and also the scope of our intervention or methodology. So we only identify the contaminants of concern, specify the food commodity under consideration, and also to state the proposed mL. So we have to define our hypothetical mL by using the methodology explained by Amin. For example, we can have another scenario. We have already established mL, and we want to have less than this mL. For example, we have 0.2 milligram per kilogram. We want to establish 0.1 milligram per kilogram. So then we can apply this methodology and to see if the new mL that we want to establish will give us, let's say, benefits in terms of intake. If this mL will reduce more the intake, and it seems that we will have our consumer more protected by the new mL established. So we have to apply this methodology also. And also we have to describe the regulatory context of rationale. For example, if you want to have a public health or trade concerns or alignment with JECFA, so it depends on the target, it depends on what we want to do with this with the calculation. Second step is to collect data. So it's really important. We can't do it if you don't have data, because we will use the dietary exposure assessment. So occurrence data, food consumption data, and also body weight and target population. Since exposure is often expressed relative to body weight, but body weight we can take as a reference value 70 kilogram. But if we want to do this approach considering infants, we have to change the body weight that correspond to this population. And then we do as I mentioned, our first calculation to estimate the baseline intake, and then we use the data that we collected before, And we have the formula that you know very well. You have consumption data multiplied by mean concentration, and we divide by body weight. We can use the deterministic approach depending on data availability. After this calculation for baseline exposure, we calculate a new intake estimate or new dietary exposure by using and replacing data value of occurrence with hypothetical mLs. And we use the food consumption data. We will have a new result from this calculation. And after that, we estimate the estimate exposure under this hypothetical ml, and we calculate the reduction rates when using both of the two calculations. The formula is really very easy to apply. And then we can summarize all our output, our exposure estimates under all scenarios, and we will have a very good idea about all the benefits that we can have by taking into account all this maximum or hypothetical maximum level. And we can highlight in this table the exposure reduction, feasibility of mLs by also taking into account simple rejection rate, and also the potential impact on trade by analyzing this simple rejection rate. And this analysis will provide a clear and evidence-based recommendation for the establishment of mLs. It's very simple application. We can as you see here, it will give you really a good idea about all the propositions that we can have regarding the mLs. And if we look on all the reports of the electronic working group within the Codex framework, we will found the same methodology applied by the different working group. So as a recommendation for the application of this methodology, so with appropriate investments in data generation systems, Arab countries can adopt this methodology to enhance consumer safety while supporting trade, food trade, and regulatory harmonizations. So first of all, we have to strengthen national contaminant monitoring program and encourage regional data sharing to improve the quality of occurrence data. Also, we have to conduct national food consumption survey. It's very important. As you see, among all the parameters that we use in our calculation, we have consumption data. So we have to do this survey to generate our own data. To enhance regional cooperation for technical capacity building and harmonized risk assessment practices, use the appropriate to set science-based mLs, protecting consumer health while supporting fair trade in our region, and to integrate the methodology into national food safety regulation to ensure consistent and transparent decision-making. So it was my last slide. Thank you very much for your attention. I hope that you had all the methodology linked to the establishment of mLs. So thank you very much.
So we had an amazing overview about how to get to an ML. I guess the first question that we need to have is, do we need an ML? And when do we need an ML? So that's essentially what I would like to very briefly go over before we get into the let's get an ML, okay? So first of all, I would like to ask you, how do we determine that there is a problem with a contaminant in food? How do we determine that? We know that there is a hazard. So for example, we know that lead is a problem. We know that lead may enter into a number of food ingredients. And therefore, I want to know if, and I know basically that lead has detrimental impacts on health, detrimental impacts on children, detrimental impacts on adults. And I want to know, how can I basically reduce the potential health impacts of lead? So I use lead, but I could use, for example, arsenic, same type of approach. So the way I do it is, when I do a risk assessment, and for most of the chemicals, I will have the hazard characterization. What does the hazard characterization give me? The hazard characterization gives me the potential impact of the substance, of the hazard, on my health. Generally, hazard characterizations lead to what we call health-based guidance values, HBGV, health-based guidance values. These guidance values are determined in such a way that we know when you have an exposure, so this is the exposure, at this level, anything at this level or below will not represent a health effect on the population, okay? Generally, for what I call threshold chemicals, do you know what I mean by a threshold chemical? It's a chemical for which I have a threshold. So I know that with this threshold, below it, I should be okay, okay? And there is a threshold potentially that can lead to something, okay? Now, I want to ask you very quickly, because we're not going to do the hazard characterization. If I put the health-based guidance value here, does this mean that when I'm here, there is a problem? No, because these health-based guidance values are set with buffers of safety, and generally big buffers of safety. So if I'm above, nobody's going to die tomorrow. And let's not forget also that here, and this is a reminder, that we are talking about chronic exposure. For chemicals, we are not actually talking about somebody's eating something and he's going to be actually getting sick even. Not talking about death here. We're talking about not getting sick. We're talking about a potential impact on health over a lifetime. And in fact, these values, and by the way, the values that I will determine here, I'm going to call it a TDI, a tolerable daily intake. Okay? A tolerable daily intake. الجرعة اليومية المسموحة, I think I will, yeah. Okay? المسموح بها, okay? So this is the tolerable daily intake. This value is determined as being an acceptable value for a chronic exposure over a lifetime with a consumption every day. I'm consuming every day over 70 years. This is essentially how we consider. So it's chronic exposure. So anything above, not really an issue. So when I'm trying to determine whether it is an issue or not, what am I going to do? I'm going to be basically looking at, so once I know that this is my health-based guidance value. Now, when I do a risk assessment, I compare the hazard characterization and the exposure assessment. So I'm going to be doing my exposure assessment. And do you remember, how do I do my exposure assessment? I'm going to be looking at the various foods where that chemical may occur. and I'm going to be looking at the occurrence that I may find in those foods. I'm going to be looking at the consumption of these foods, and I'm going to be trying to estimate what is the overall exposure. Generally, what I come up with is what I call a PDI, a probable daily intake, a probable daily intake. And what do I want? I want this to be as big as possible. I want this to go here, here, here. I want to basically go as low as I can, right? So the principle of risk management is what? The first principle that I want is ALARA, as low as reasonably achievable. If I can actually avoid things from getting there, I should avoid that. So when I consider that this is my element here of management, what do I need to do in order to apply ALARA? First of all, I need to, and now we're going to be talking about risk management. Okay? Risk management interventions. So in order to, my guidance is this. This is my guidance. This is what I want to do. First of all, if I find any point of introduction, I'm going to eliminate it. So eliminate points of introduction. So example of points of introduction. So for example, for lead, any instrument that might be used in conjunction with food production should never contain any lead in it. I ban lead from use in any food processing or preparation practice. Okay? No point of introduction. Okay? Even an industrial contaminant. I'm going to basically say that if you have, for example, a potential source of dioxins, for example, I have an industrial zone, I'm going to say, you know what? No food factory will be set in this area because there is a potential industrial waste here. And if there is industrial waste, I'm going to be basically trying to avoid that. Another big point of introduction, remember, for animal-derived foods, most of the points of introduction come from feed. Okay? So I'm going to be controlling feed. By controlling feed, I'm going to be actually controlling food. So you see, basically, elimination point of introduction, and I'm going to try in my elimination of points of introduction to go as early as possible in the supply chain. So when I'm doing that, what am I doing? I'm doing preventive controls. In fact, this is a key element that you have to think about. We should not be controlling contaminants in food by setting MLs and by chasing end products, by chasing end product testing. Because when you do that, it's already too late. You allowed the contamination to happen. You're having food that is contaminated unduly. Okay? So that's absolutely not acceptable. You know, you should be trying to prevent the food from getting contaminated. But now you have all these, and in some situations, and particularly for international trade, some of these are difficult to enforce. Because when I am controlling, if I take the example of lead, when I'm controlling, for example, the ban of the use of lead in food manufacturing processes, I can do that domestically. But I'm not going to go to your country to check, are you doing that? Are you actually preventing people from using lead in spice production or in maple syrup production? Or I cannot do that. So when I cannot do that, I need to find other measures that will support these to be consistently applied. And that's where the idea of maximum level starts to be created. So I'm going to go back now and to consider, when do we consider maximum levels to be a useful tool? Generally, you have two conditions that would need to be present for that. First of all, when you see this PDI, as we said, this PDI is coming from the contribution of several food, right? So for example, I'm going to say I have a contribution of wheat, I have a contribution of seafood, I have a contribution of rice, I have a contribution of spices, I have a contribution, I don't know, of fruits and veg, okay, etc. So I have several foods where these contaminants may occur. When I want to now decrease the exposure, remember what I want? I want this to be bigger, okay? If I have that wheat contributes 5%, seafood contributes 10%, rice contributes 30%, spices 1%, fruits and vegetables 2.5%. An example, just random, okay? How did I do that, by the way? Again, I did an exposure assessment. I determined my PDI, and my PDI actually was based on the contribution of these different commodities based on the survey that I conducted and the conduct of this exposure assessment. So in accordance to you, if I want to push the exposure down, which commodities I'm going to use the most? I'm going to use the one that actually has a potential for high contribution. So this is one of the ones that I'm going to be using. However, if I know that rice, but this is an example, if rice is very limited trade, this is not the right case, okay? But in fact, this is the real right case where probably an ML is used. If this commodity was mostly produced and consumed domestically, would an ML be useful for international trade? Probably not. For domestic trade, it would be probably good, but for international trade, it wouldn't be. So the second consideration is that the commodity is traded internationally, and there is a potential for different levels being set by different countries, creating some problems in trade. Second conditions fulfilled. So you see, I have a public health issue. I want to reduce the exposure. It's a priority chemical. It's occurring in a food that is representing a priority, and it is commercially traded internationally with the potential to create an issue on trade. Okay? A second consideration, spice, 1% of trade, not much. Okay, sorry, 1% of exposure, 1% of exposure contribution, 1%. I look at trade incidents, and I'm looking lots of problems with contaminant X in spice, contaminant X in spice, you know, rejection. I have a problem in international trade. I need to create more consistency. I need to create a system where it's fair trade consideration. I'm going to be looking at that, and I might be setting an ML. Okay? So those are the two types of considerations that we can set. Now, I'm going to give you an example where this is at the domestic level, based on our own experience in Canada. Okay? If I take lead, okay, maple syrup, we don't drink maple syrup in Canada. We don't. You know, you use it every now and then, just like, you know, you use sugar, but mostly, you know, on crepes and these type of things, but you don't drink it. It's not a staple food. But there is a potential of occurrence of lead in maple syrup coming from where? Coming mostly from this, from points of introduction. From points of introduction, meaning in the manufacturing process, you know, you need to boil the maple sap. You extract the maple sap and you boil it. If you're boiling it in a lead-based container, some of the lead will come out, okay, and will migrate in there, right? So You ban that. But people are not doing that, they are not following that consistently. You're not going to be putting a policeman in every place that they are doing that to check if they are doing that. And you know what? You're finding that basically you do some surveys, you do some action, you find the way you manage that is, how do we manage that? We want it as low as reasonably achievable. So we get some samples, we do a risk assessment. If we find that the levels are higher than what we are used to be seeing based on the background, we say, there is a problem there. We investigate, we find somebody using it, we ban it. Sometimes we want to say, well, you know what? I'm not going to be doing that at the main manufacturer, because the way the production is done, you have small producers and you have a big buyer that buys the syrup from different small producers. They gather things and they put it there. And sometimes we assess that, and sometimes we find values above, values below. What are we creating? We are creating unpredictability in the system. Because we are creating unpredictability in the system, and even though maple syrup does not contribute in a significant way to the exposure to lead, we decide to set a level for a maximum level for lead in maple syrup based on a baseline level and based on a rejection rate. But this is for domestic purposes, just for domestic purposes, in order to be able to create more predictability in the system. So you see how you set a maximum level? You set a maximum level primarily as a tool to support ALARA to push down the exposure, but also to support more predictability into international trade. You find also, and I will finish with this, now you find countries in the world where if you see the list of their maximum levels and products, you find a long list. Other countries have a short list. Does this mean that the country that has a short list is less protective than the country that has a long list? No. They are using different approaches of risk management. Each of them is comprehensive in their own way. So the first one, probably because they do not have a better handle on their points of entry, potentially, they need to have, for individual levels, stronger controls for individual food commodities. And frankly, that's what happens with the European Union. The European Union is a grouping of countries of different types, particularly of domestic inspection. So I want to see the same level of protection. I want the person who is in Slovakia to be the same way protected as a person who is in Spain, in France, or in Germany. But the European Union or the European Commission does not have oversight on inspection, on enforcement. They have oversight on standard setting. So in order to create a uniform system, I'm going to be creating more things to control such that I'm going to be having a more uniform approach of protection. Okay? And that's the approach that they have chosen. In other countries, like Japan, Canada, the United States, Australia, and New Zealand, we will use less of this. Why? You have the same inspection system. It's a federal inspection system. It's a one-country inspection system. So you set your standards. You have the same inspection system. You marry what you do domestically with what you are doing internationally. At the end of the day, you are pursuing a food safety objective. The food safety objectives are probably similar. It's just that you are using different tools to achieve them. Okay? And I will finish with this.
Prof, should we take in consideration the uncertainty level, plus or minus figures, when taking a decision to accept or reject, whether it's exceed ml or what's the right practice dealing with that?
Absolutely. When you have any type of analytical measure, you do not take the value as an absolute value, and you have to account for the standard deviation of your analytical method. So anything that is within the uncertainty factor, you would not reject. So you would have to be higher than the number plus the standard deviation to be in the zone of a potential rejection. And sometimes you would be even building even more buffer on that. Why? Once again, because when you set an ML, ML plus immediate X doesn't mean that there is an issue. It's simply a non-conformity, okay? So you set a policy for non-conformity that is taking into account the uncertainty factor and the standard deviation. Okay, you have to account for the standard deviation of your analytical method. No, I mean, again, you do not want, you still remember that you want still to reduce this, okay? So you do not, because if you are doing that unlimited, what's the point of having an ML? You still need to have an ML, okay? It's just that I'm not going to tell you, like sometimes that value is a national policy. There is guidance provided by Codex, mostly for pesticides. You have guidance that is provided there. For contaminants, it's generally left to countries' policies, but the general direction is absolutely to account for the standard deviation, okay? And the more your method is precise, meaning that your standard deviation is more restricted, the better it is, of course. I think with that, we've reached lunchtime. The afternoon is actually a little bit crowded, so you have a lot of activities. So you're not coming back here. يعني بعد الغداء ستذهبون إلى القاعات. كل يعني الفريق البرتقالي والفريق الأخضر سيذهبون إلى القاعة التي أسندت لهم وسنلتقي بعد العمل الجماعي الذي ستقومون به بعد الغداء. فالرجوع بعد الغداء على الساعة 1:15 في القاعات. شكرا جزيلا للجميع وشهية طيبة.
Research knowledge we share with pride for a world where health is on our side. Collaboration and science as pillars.
إلي
وين منتصر؟
إلي the camera اللي أنت عاملها now يعني the camera اللي working now اللي showing sound glitches.
Oui, oui, on a eu un problème avec le table. Je le règle.
Ah bon, ok, ok.
هذا اللقاء التدريبي. وسنبدأ كما تم الاتفاق عليه بتقارير من قبل مجموعات العمل التي يعني عملت لمدة الساعتين السابقتين. المجموعة بعتقد هناك مجموعة برتقالية ومجموعة خضراء، right؟ سنبدأ بالمجموعة البرتقالية الأول. فمن تم انتخابه أو انتدابه للقيام بعملية التلخيص، شكرا جزيلا. Thank you. Yes, please, no, so please. So Mohandes Hadi from Libya will be presenting the recap. تفضل.
بارك الله فيك، شكرا بروفيسور. بارك الله فيكم على الفرصة، أول فرصة لي أتكلم، فشكرا جزيلا لكم. فيما يخص المجموعة البرتقالية، تكلمنا برئاسة الدكتور أمين حول كيفية how to set up an ML يعني limits لعنصر معين، وكان الاختيار في هذا المثال للليد. السبب في هذه يعني في البريك اوت سيشن كان كيف نتمكن من أخذ الداتا، تحليل الداتا ودراستها ووضع ML معين. المثال كان وثيقة تم عرضها خلال اجتماع CCF 18 الذي كان من شهر أو شهرين تقريبا في بانكوك في تايلاند. هذه الوثيقة طبعا سبب اختيار هذه الوثيقة وفق الدكتور أمين قال أن يعني أنها وثيقة ممتازة جدا توضح الخطوات من البداية، من بداية جمع البيانات وحتى الوصول إلى إعطاء المقترح حول سيت اب للإيميل. فهذه الوثيقة تعطي تحليل دراسة الأوكيرنس داتا في الليد في سبايسز ميكستشر. الجيفكا قبل الاجتماع قامت بدراسة الهازارد اناليسيس، وقالت ان يجب ان يكون هناك ML للسبايسز ميكسر في للليد في سبايسز ميكسر. ووفق قامت الكترونيك وركينج جروب دراسة المعلومات المتوفرة في الجيمس فود حول الليد في سبايسز ميكسرز. هناك حوالي 14,000 مدخل أو داتا سامبلز موجودة في جيمس فود. تم الاختيار منها حوالي 5,000 تقريبا داتا أو سامبل، والتي تم يعني it was categorized as spices. So that's the first question, and the exercise was based on was structured based on a question. So there was different question, and we were divided to different groups to answer those questions. So the first question was why choosing only 5,000 plus samples from the 14,000 samples, and that was the answer. Those was categorized as spices. The second question was regarding the geographical التقسيم الجغرافي للدول التي قدمت البيانات، وكانت هناك مجموعة من الدول التي قدمت من الاتحاد الأوروبي، من المملكة المتحدة، من عربيا كان هناك المملكة العربية السعودية، كان هناك أعتقد الهند والولايات المتحدة وغيرها. فكان هناك تنوع جغرافي يعتبر مقبول نوعا ما. كان هناك ملاحظة بأن لا توجد هناك مدخلات من أفريقيا، وهذه أعطت ملاحظة يعني عندما لا تقوم الدولة أو المنطقة بإدخال المعلومات الموجودة لديها، فهنا يعتبر ستيب باك، ويعتبر عائق لهذه الدولة نفسها، العائق الذي للدولة التي لا تقوم بإدخال البيانات، ليس عائق للمجتمع أو المجتمع الكودكس. فعموما باختصار التنوع الجغرافي للبيانات المستخدمة في هذه الدراسة يعتبر مقبول. طيب ندخل الآن للعملية الحسابية التي قامت بها هذه الورقة العلمية، وهو الفريق العلمي الذي قام بتجهيز هذه الورقة. الكودكس سكرتاري قام بتجهيز هذه الورقة، وضع حدين افتراضيين للML، وهو كان ML 2 وML 1. والنتائج التي جمعت للحدود الافتراضية هذه، أو المين كونسنتريشن، المين أو المتوسط كونسنتريشن للليد، إذا كان لم بدون ML أو نو ML كان 0.6، للML 2 كان 0.21، والML 1 كان 17. والريدكشن ريت أو مستوى الانخفاض كان مقبول، يعني من الزيرو للنو ML، الML 2 كان أقل، كان 1.9، والML 1 كان 5.1. الريدكشن ريت كما سمعنا في المحاضرات التي ألقيت علينا صباحا، أعتقد صباحا، كان إذا كان فوق 5%، لا الريدكشن ريت فيما يخص التجارة، إذا كان فوق 5% فهذا يعتبر غير مقبول، يعتبر كأنه barrier for trade, so it will be rejected. So for both cases it was below 5%. So in this case, so both of them are accepted. So this is one of the questions within the exercise, to calculate the mean concentration and to calculate the rejection rate. So moving forward, we're going to the consumption data. So we need in this specific study, there was four categorization or four groups. So we have children, we have adults, we have the medium consumer أو المستهلكين المتوسط أو الطبيعيين، والأشخاص الذين يستهلكون الميكستشر بكثافة عالية. ففيما يخص الأطفال والأدولتس، كان المين كونسامشن أو معدل الاستهلاك المتوسط كان 3.8 للأطفال، وللأدولتس كان 5.3، والبرسنتايل 95 أو المستوى العالي من الاستهلاك كان 10.4 للأطفال و11 للأدولتس نقطة فقط. كان الوزن المتوسط للأطفال 20 كيلوغرام، والوزن المتوسط للأدولتس 84 كيلوغرام. ومن ثم الآن حسبنا الكونسامشن ريت. الآن السؤال الذي بعده أو النقطة التي بعدها، وهي حساب البيس لاين انتيك، وهو المستوى الأساسي من الجرعة التي يتم التحصل عليها من الكونسامشن، وحسابها بمعادلة بسيطة: المين كونسنتريشن ضرب الكونسامشن تقسيم البادي ويت، وعلى هذا الأساس يتم حساب البيس لاين انتيك للأطفال، للأدلتس، للاستهلاك العادي والاستهلاك العالي، وهذا كذلك تم حسابه. النقطة التي بعدها هو الانتيك افتر الML ابلكيشن، فهذا كان في النو ML ابلكيشن، ومن ثم نحسبها نفس الانتيك او البيس لاين انتيك للML 2، ومن ثم حساب من جديد للبيس لاين انتيك للML 1، حتى يكون عندنا قيم للثلاثة افتراضات، بدون ML 1 والML 2. وبعدها يتم حساب الريسك كاركترايزيشن، وهو حتى يتم معرفة أي ML يمكن الاعتماد عليه، أي حد يمكن الاعتماد عليه أو اقتراحه للCCF. فتم حساب، وهناك معادلتين يمكن الحساب الريسك كاركترايزيشن على اساسها. المعادله الاولى هي حساب الريدكشن برسنتج، او حساب البرسنتج للBOD. بالنسبه لحساب الريدكشن او مستوى الريدكشن، في حال ان استخدمنا ML2 كم يكون الريدكشن، او حساب الML 1 كم يكون الريدكشن، ونفس الشيء بالنسبه للبرسنتج اوف BOD point of deduction. تم حساب هذه المعادلتين، يعطوا نفس النتيجة، أرقام مختلفة ولكن نفس النتيجة، نفس المعلومة. عندما تم وهنا قمنا بحساب percentage of POD. عندما يتم هذا الحساب تمت ملاحظة بأن عندما نقوم بحسابه للأطفال وللأدلتس وللاستهلاك المتوسط وللاستهلاك العالي يكون هناك انخفاض طبيعي. القيم لا يتم الاعتماد عليها كقيمة بحد ذاتها، ولكن يتم النظر إلى نسبة الانخفاض للبي او دي. والمرجع الأساسي كان وهو بالنسبة للأدلتس مستوى ضغط الدم، وبالنسبة الذي يؤثر في ضغط الدم يسبب في ارتفاع ضغط الدم بالنسبة للأدلتس، ويسبب في انخفاض للاي كيو بالنسبة للفئات الأطفال. وبالتالي هذا على أساس قامت جيكفا باقتراح أو برؤية جيكفا بأن ضروري أن يكون هناك ML للليدز في الميكس سبايسز. بعد دراسة رأينا أن هناك انخفاض، مستوى الانخفاض ليس significant، يعني بالنسبة للchildren كان عندما لا يكون هناك ML، عندما لا يكون هناك NL كان المين اوف POD 3%، عندما استخدام ML 2 عندما يكون ال ML2 المين percentage of POD يصبح 1، وال ML1 كذلك يصبح 1%، فهو ليس هناك اختلاف. نفس الشيء بالنسبة هذا بالنسبة للاستهلاك المتوسط، نفس الشيء بالنسبة للاستهلاك العالي. فيما يخص فيما يخص الأدلتس، فيما يخص الأطفال كان البرسنتج من 19% نزلت إلى 7% عندما نستخدم ML2، وتنزل إلى 5% عندما نستخدم ML1. نفس الشيء بالنسبة للاستهلاك المتوسط، ونفس الشيء بالنسبة للاستهلاك العالي. الخلاصة بأن الأرقام يعني الاختلافات ليست significant، فكان المقترح المقدم من قبل فريق العمل الإلكتروني أن يجب أن يتم هناك اعتماد ML، ولكن أي ML سواء كان 2 أو 1 يعني that's up to the committee, to the CCF, maybe 19 to decide whether to take ML2 or ML1. باختصار هذا ما تم مناقشته خلال البريك اوت سيشن رقم 1، ولا أعرف إذا نسيت شيء فسامحوني. بارك الله فيكم.
شكرا جزيلا مهندس هادي. هل هناك مداخلات أخرى من الفريق البرتقالي؟ يس، من الأخضر، من الفريق البرتقالي، يعني نفس الفريق، فريق
أكيد في بعض النقاط يعني سقطت سهوا.
أنا in fact actually if I want to very quickly here, there is a key message that I would like to get out of this. Okay, so if we go back, we had the probable daily intake. Works. So we had the probable daily intake that we had as a starting point, right? And by imposing the ML, you are trying to reduce the probable daily intake. You're trying to get it down, right? So basically the first reduction, and you had the second reduction, right? And the first ML, which is essentially, this is the 2 ppm, and you had the 1 ppm, right? The first reduction gave you a certain, the 2 ppm made you a first reduction. This one allowed you to have also another reduction of exposure. This difference was found to be marginal. This difference was very limited, whereas with this one, you have a rejection rate of about 2%. Was it 2%? And this one was led to 5%. So for a very small gain in public health, you are more than doubling your rejection rate. And this is essentially the discussion that happens if I'm not gain anything, and this was really not much, actually close to nothing in terms of proportion that was being gained, and I'm doubling the rejection rate, I'm going to be choosing this one for international trade, because this already gives me a very appreciable increase in the reduction of exposure. And this is what I'm trying to achieve. Okay, so this is one of the key learnings from this particular exercise. Thank you so much for that. الآن نمر إلى الفريق الثاني، الفريق الأخضر. المجموعة الخضراء، الفريق الأخضر. المجموعة. You just did a great job. So please. That one, or maybe take one.
Of course, we have a lot in common with the other group. Basically, we were working on a study made by Jack. The study was to try to set new MLs for lead in two kinds of food, the dried bark and the dried culinary herbs. So basically, we worked in parallel with them as if we were doing the study. We did the same steps as he mentioned previously. So what I'm going to talk about were the al-araqil, or the things we thought were a little bit of a problem for us, because it was the first time we do this kind of study. So mainly, I think because it was the first time we were trying to extract data from an article. So this was the main problem to us. It wasn't a problem as much as it was a little bit hard to find the right numbers, because in articles you have many numbers, and sometimes the number of samples will be reduced later on because of outliers, because of many things. So you have to carefully read it in order to extract the right data that you will need for the calculation. As for the calculations, they were basic. I think no one had a problem with that. The other thing is that we noticed that there were difference in the units used in the article. So كان لازم نعمل يعني نغير الunits، نعمل the right calculations in order to use the right numbers in the calculation. So also, we reached a percentage of reduced intake rate and the percentage of rejection, and شاورنا وعطينا رأينا in order to have the balance, as previously said, between the two, to decide whether or not to set new MLs and which one are the المناسبين, the convenient one. Thank you.
So again, I think the two exercises are going really in the same direction. I think we're all seeing, first of all, the importance of the data and its availability, the importance of the selection of the data that is useful, and on the basis of what we make a decision to exclude some data, to focus on some specific data. Then, of course, the analysis that we have to conduct of the data, analysis, adequacy of the data, the way the data was generated, the analytical performance parameters and their potential use, all the aspects related to the data that will need to be excluded versus the data that will need to be included, the units by which the data is expressed, because if we are to use the information, we need to make sure that we make the right conversion, because otherwise you will be finding some errors in the results. And then, of course, at the end, we are doing this to complete an aspect of the risk assessment, which is the exposure assessment. And I think with that, you're all leaving with something that you will remember until I don't know when, hopefully forever, which is the equation that says that exposure is equal to. Okay, so consumption multiplied by occurrence. I think we're good. Yeah, I think you're dreaming about it tonight. Yes, it's okay. But you know what? That's my prof, habit, which is to make you repeat the same thing 10 times and even more until this is part of the 5% that will not evaporate after the meeting, because whenever we meet and we discuss something, 95% evaporates. 5% will remain. This is part of the 5% that will be staying, okay? And then, of course, after that, it's really the discussion about what we do with the exposure that we calculated and actually comparing that with the rejection rates in order to ascertain basically what type of decision we make. Do we take an ML? Is the ML actually achieving the objective that I'm pursuing? Is the ML producing unforeseen results, such as really potential hurdle to trade? And that's not what we want in the context of Codex. Okay. Well, I think with this, we are reaching the end of today's workshop. And actually today and yesterday's workshop has been really an interesting. Yeah, I won't need this anymore. Thank you. So it's been really, thank you very much, Habib. It's been really an interesting couple of days. Thank you for having maintained your level of engagement for this particular period. I think Eli has prepared a general overview for us for the couple of days. So we're gonna actually just reminisce the 2 days in pictures, just to review what we have been doing over the last 2 days. I think an illustration of the amazing reactivity of the team that we have, and particularly of Eli. So really a round of applause to you again, Eli, for this. And before we move actually to the closer of this meeting, with thanking all those who made this possible, it is really the time to acknowledge your participation and the delivery of the certificates of participation. And I would like to invite Professor Hussein bin Sarah al-Masrouri, the Director General of the Center of Food Safety and Quality on the stage to also support the distribution of the certificates of participation. Please, Professor Hussein.
هبة محمد. ومن مصر مريم أنسي. نهى محمد عطية. من لبنان كريم يوسف جبران. لما جبل. العالم. من العراق نغم خالد. آلاء عادل. ومن تونس سناء جاب الله. فاطمة شرفي. من الأردن شاهد سمير. أحمد علي عبد الله. ومن قطر زينة عبد الحليم أبو الجلالة. أميرة محمد الشافعي. من السودان هدى عواد. ومن المغرب أحمد جعفري. من السودان نهلة محمد عبد الله. من اليمن أكرم محسن. محمد علي سعيد. حسن سعيد سالم. والآن ننتقل إلى زملاء سلطنة عمان. مروة محمود. عمر طالب الفارسي. أفراح صالح سعد. هاني سعيد. مريم محمد الفارسي. سليم. هلال خميس علي. محمد زاهر الفندي. أحمد حمود طارق. عينة خميس. Pardon? محمد. طب راشد. اسمع يوسف. الزعري حمدان. مشاعري العبري. حمدة سعيد سالم. إسراء محمد.
مرة أخرى يعني congratulations to everybody. يعني الشكر الجزيل لكم جميعا على المشاركة وعلى المشاركة الفعالة خلال اليومين. يعني a big round of applause to all the participants. Truly, thank you. ختاما طبعا we have to thank all those who made this event possible and a reality, and obviously starting with our generous hosts here in the Sultanate of Oman, without whom this event would not have been made in the way that it was made, and we would not have felt in our country like we do every time we come to Oman. So I would like really on behalf of all of you, all of us, to thank again all our hosts in the Sultanate of Oman, starting with again, the Center of Food Safety and Quality in the Ministry of Agriculture, Fisheries and Water Resources, at the helm of which is Professor Hussein, bin Samah al-Masrouri and all his team for actually the support that we have received and the kind welcome. So again, thank you so much for making this possible. Thank you. Of course, to all the organizations that enabled this to happen, obviously, the Arab organizations under which the Arab Codex initiative is being implemented, the Arab Industrial Development Standardization and Mining Organization, ETSMO, the GCC Standardization Organization, and all your competent authorities that actually enabled you to participate, to all these organizations, we say thank you. Thank you very much for enabling that. To, of course, those who enabled the funding for this event to happen, our thanks and appreciation to the US Codex office in the US Department of Agriculture. Thank you. And of course, to the organizations under which this event is being implemented. So the International Union of Food Science and Technology, a Codex observer, and its disciplinary group for food regulatory science, the Global Food Regulatory Science Society with its entire team. And really my privilege now to thank the scientific team who made this event possible. Dr. Amin Assoud, Dr. Karima Sween, Dr. Eli Bouyazbek, Dr. Mustafa Sultan, and all the team who is not here actually who provided input in the preparation of the material. To all those who enabled the operations and the organization of this event, many of which actually you have been interacting with for some time. So here with us, Naira Al-Sharif from our Cairo team. Somebody who you're not seeing, but he's probably behind his screen right now, supporting the Zoom operation. Montassar Guider from Tunisia. A new addition to our team here in present here with us, Habib Hadouaf, based in Paris. أيضا كل الفريق المساند في جمهورية مصر العربية، مصطفى فوزي، محمد فوزي. They helped actually prepare all the material and enabled us to be ready for this event. And somebody that you probably haven't heard of and has been really working on our web postings and so on, Kenneth Tang in the Republic of Korea. So to all those who made this possible, I would like to say thank you. Thank you for all your support. Now, we will be taking a lot of the recommendations that you made during the discussions that took place during this meeting. We'll summarize them. And I have actually a suggestion to you that at the next Arab Codex coordination meeting, you elect 1 or 2 spokespeople who will be presenting the outputs of this training on behalf of this group to the Codex contact points, many of which did not attend, so that they can hear the outputs and the recommendation. And it is a way for these recommendations to be recorded and to be lifted up the line to the Arab organizations, and particularly through ETSMO and through the Arab Codex Initiative. And مسك الختام أعطي الكلمة للدكتور البروفيسور حسين بن سمح المسروري، المدير العام لمركز سلامة وجودة الغذاء في سلطنة عمان، لاختتام هذه الدورة. شكرا بروف حسين.
شكرا بروف سامر. I will do it in Arabic. سأتحدث باللغة العربية. أجدد شكري طبعا إلى الزملاء في المنظمة العربية العالمية لعلوم تشريعات الأغذية، وللمبادرة العربية أيضا، أولا لاختيارهم سلطنة عمان لعقد هذه الورشة، وربما يعني تم إقرارها خلال 3 أسابيع أتوقع بروف سام. فشكرا بروف سام لاختيار سلطنة عمان لاستضافة هوست هذه الورشة، وأجدد شكري مجددا. وربما إذا تأذن لي أضيف أيضا يعني بعض الزملاء من المركز اللي يمكن ساعدوا أيضا في خصوصا تسريع استخراج التأشيرات للمشاركين بدون ذكر أسماء. الشكر لهم جميعا، جزاهم الله خير. أتقدم أيضا بالشكر لكل المشاركين من دول الإقليم على طبعا أيضا تقشمهم معنا السفر. ربما بعض الزملاء من بعض الدول العربية يعني سفرهم كان ربما مرهق أكثر من الآخرين، فشكرا لكم. وأتمنى أن طبعا استفدتوا من هذه الورشة. يعني حقيقة أنا لما I'm not a food scientist، مش مختص في علوم الغذاء، ولكن لما أتحدث مع زملائي أرى أن أحيانا في جاب يعني بين الناس التحليليين وبين الناس المنظمين وبين الناس اللي يشتغلوا في المواصفات. لكن مثل هذه الورش دائما يعني تزيل هذه الجابز بين مختلف الموظفين اللي موجودين في مختلف الدوائر، وتضع الجميع في قالب واحد. كل شخص يفهم ماذا يقوم زميله في الجانب الآخر. أحيانا للأسف ربما الشخص التحليلي ما يفهم أو ما يعني يكون ملم بكل الأشياء اللي يقوم بها زميله في المواصفات، والعكس صحيح. لكن مثل هذه الورش، واللي حقيقة أنا أيضا مقدر أن أشكر الجي فورس والمبادرة العربية، لأنهم يعني يبذلوا جهد كبير في البيلدينج كاباسيتي اللي لدول الإقليم في إقليم الشرق الأدنى، خصوصا الدول العربية. فشكرا مجددا بروفسام لكل الجهود ولكل الأعمال اللي تقوموا بها لرفع كفاءة الموظفين في دول الإقليم. أتمنى أن ما نكون قصرنا في حقكم، ونرجو المعذرة. يعني إن كان يومين ربما يعني very tight from من أول الصباح إلى نهاية اليوم، فنعتذر على أي تقصير. ونتمنى إن كان لكم من وقت أنكم يعني ربما تستغلوه في جولة في مسقط على الأقل في المساء إن شاء الله. نتمنى لكم كل التوفيق، ونراكم إن شاء الله في فعاليات أخرى. شكرا لكم جميعا.